Good afternoon, bacha log. Good afternoon, everybody. Welcome to this beautiful session. Revision through question series is going on, and today we are going to discuss another subject, another very heavy weightage wala subject, that is theory of machine and vibration. Already few subjects have been covered by Negi sir ka subjects have been covered. Approve sir has taken one class, and today I am going to take one session on theory of machine and vibration. And believe me, today in this session, today's session, we are going to discuss all those chapters, all those topics which are very, very important, which are very, very relevant from the exam point of view. At this moment, there is no point, revising all the subjects, revising all the syllabus now, because very few days are left. Hardly 10-12 days are left. And in these days, you have to focus only on those things which are very, very important. And for this reason, I am here and I have brought few questions which belong to very important topics like simple mechanism, gear and gear train. There are going to be some questions. Some questions are from vibration. In fact, vibration say I have taken huge amount of questions. So depending upon importance of the topic, I have taken some questions over here, beta. So first of all, please let me know, everybody, that my voice, audio, video, everything is clear to everybody or not. Please let me know, audio, video, is everything clear or not? Great, 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 great. So, shall we begin? Shall we begin? Already few sessions have been conducted today. Basic thermodynamics is done, engineering mechanics is done, mathematics wala session is already done. Mathematics wala session is already done. Material science based Swadesh has already conducted session. And today I am here on 23rd of January. I am going to conduct this session. And after me, Amit Maurya sir, Aditya Pal sir, Approve sir, and Sandeep sir are going to be, with their sessions. So these sessions are going to be very, very important. So let's begin. The very first chapter, which is very important here, that is simple mechanism. And simple mechanism may, let me write those topics which are very important from the exam point of view. Examination may, they are going to ask questions. There are huge chances that you will get questions on degree of freedom. The very first priority. Second may, you can get questions from Grashoff's law. Okay, na? And third, you may get questions from quick return motion mechanism. And believe me, beta, you have to cover all three quick return motion mechanism. Whatever we have studied crank and slotted lever quick return motion mechanism. We have studied Whitworth quick return motion mechanism. We have also studied offset ladder crank mechanism as an quick return motion mechanism. So all these three quick return motion mechanism you have to be very well comfortable with, because examinations may nowadays they have started asking questions on Whitworth also. Okay, na? So these three are most important topics from where in GATE 2023 you can expect one question, at least one question from each topic. It will not be a surprise for me if from each of these topic one question is going to be there. Okay, na? Acha. The very first question which I have kept in front of you, this belongs to degree of freedom. They will give you some kind of mechanism, and then they are asking to calculate degree of freedom for this given mechanism. How can we do that, beta? Degree of freedom ke liye we have a very small formula, Kutzbach equation we have. I hope you remember. Let me tell you a brief. Degree of freedom ke liye you are going to have one formula. F is equal to 3L minus 1 minus 2J minus H. This is going to be the basic formula. Sometimes if question they have made a little bit tough, they may include some redundant link wala concept. They may also include redundant degree of freedom wala concept. Getting my point? So if such things are there, you have to take care of these things. If redundant link is there, you don't have to count that link. You don't have to calculate while calculating number of links, number of joints, you have to avoid this link. Redundant link, you should not count neither this link nor its joint. You should avoid this. And if you have any redundant degree of freedom, so this formula is going to be modified a little bit. This formula, Kutzbach equation is 3L minus 1 minus 2J minus H. And if any link is having redundant degree of freedom, so that thing also you have to subtract here. So these things you have to keep in mind. Okay, now coming back to this question. In this question, very easy question they have given. No link is redundant. No redundant degree of freedom is there. Basic formula we are going to use. We are going to use this formula. Calculate kar lijiye bete, how many links are there? How many joints? Those joints. This J is the number of those joints having degree of freedom 1. Number of pairs with degree of freedom 1. And this H higher pair, 2 degree of freedom wale pairs. Number of pairs having degree of freedom is equal to 2. Just try to calculate beta. How many links you can see here? Always fixed link ko we are going to call it as link number 1. So this is link number 1. 1 ke saath mein this shaded area they have given na. This is link number 2. This is link number 2. This is link number 2. This is link number 3, link number 4, link number 5, and this is your link number 6. Getting a point? Acha, this shaded area se this plate they have made na, this plate is showing this plate, it means this shaded area means this is a single link beta. This is the single link. So how many total number of links are there? Total number of links are 6. Number of links ka value 6. How many lower pairs are there? Effective number of lower pairs you have to calculate. 1 and 2 ke beech mein we have turning pair, 1 degree of freedom wala pair. So this is binary pair, 1 degree of freedom wala pair. 2 and 3 ke beech mein you are going to have turning pair. This is binary pair beta. 2 and 6 ke beech mein you are going to have another pair, turning pair hai. So this I will call it as binary pair. Add this joint, link 3, link 4, link 5. 3 links are connected. Can I say this is your ternary pair beta, ternary joint? And ternary joint ko we have to convert into effective number of binaries. Keep this in mind. 5 and 1 are connected here. This is binary. 4 and 6 are connected here. This is also binary. And link number 6 is kept on link number 1. What kind of motions are possible bete? Very, very carefully. What kind of motions are possible here? कौन-कौन सी motion हो सकती हैं? Sir, link with respect to this link number 1, link 6. Look at the shape. Look at the shape. This is your link number 1 beta. Fixed link. This is link number 1. And on that link number 1, you have your link which looks something like this. Something like this. You are having a link which looks like this. ऐसा ही तो situation है बेटा. This is link number 6 and link number 1. This is link number 6 and this is your link number 1. What kind of pair you can see here? Sir, with respect to link 1, link 6 can have 2 motions, 2 independent motions. कौन-कौन सी? What are going to be the motions? Link 6 can have translation, independent, and it can also have rotation due to its shape. So, but there are 2 independent motions possible now. So can I say this seems to be higher pair? This is higher pair. This here between link 6 and link 1 you are going to have one higher pair. So how many lower pairs and higher pairs are going to be there? There is one higher pair. Let me write. Sir, there is one higher pair. And how many effective number of binary joints? Sir, there are 1, 2, 3, 4, 5. 5 binary and 1 ternary we have. Can I write? We have 5 binaries plus 1 ternary. And whenever we have ternary joint, always remember, we have to convert this ternary into effective number of binaries beta. Always, always, always. This 1 ternary, now everybody knows 1 ternary is equivalent to 2 binaries. Let me write. If we have question like this, link number 1 is connected to link number 2. This is something we call it as binary. Link, this is binary joint. Link 1 के साथ में we have link 2. 2 के साथ में same point where we have link number 3. This is something which is known as ternary pair, or this joint is called as ternary joint, and ternary joint is going to be equivalent to two binaries. I hope everybody knows this. One ternary will be equivalent to two binaries. Similarly, if four links are there at same point, four links are there, link 1, 2, 3, 4, quaternary joint, and one quaternary joint is equivalent to three binaries. Getting a point? So using these relations, you can convert ternaries, quaternaries, penternaries, hexamernaries into equivalent binaries. Write it here. One ternary is equivalent to two binaries. So effective number of binaries, how many are there? But 5 binary plus 2 binary, there are total 7 binary joints. Put down these values here. Can I write? Degree of freedom is going to be how much? Degree of freedom F is equal to 3 times L is how much? 6 minus 1 minus 2J. J is how much, beta? J ka value we have taken as 7 minus higher pair. How many higher pair are there? Sir, only one higher pair is there. Kitna ho jayega? This value is going to be 5 3 is 15 minus 7 2 is 14 minus 1. This comes out to be 15 minus 15. This is 0. Degree of freedom is how much, beta? Degree of freedom is how much? Degree of freedom is coming out to be 0. Now people are saying option. Yes, yes, yes. Clear bete. Which option is correct? Option B, Bombay is correct. I hope everybody is clear. Which option is correct? Option B, Bombay is correct. Okay, na? So degree of freedom pe, they will ask some questions. Questions may be sometimes very straightforward, where you can easily calculate number of binary joint, ternary joint. Don't forget to convert them into binaries. And if you have any higher pair, count that carefully. Question may be made difficult if they have include any redundant link, if they have provided any link which is having a redundant degree of freedom. In that case, question is going to be a little bit difficult. So be ready for that situation also. Getting a point? Today in this session, I will be discussing some questions as well as concept of the questions, because name of this session is revision through questions. Getting a point? So I will discuss concepts also, beta. Don't worry about that. Another question. Although I have alarmed everybody that examination may quick return motion mechanism. All three quick return motion mechanism are very, very important, beta. Very, very, very important. Examination may you may expect one question from quick return motion mechanism, and now you have three options. It may be crank and slotted lever quick return motion mechanism, or Whitworth, or offset slider crank mechanism like this. So I have this question which belongs to offset slider crank mechanism. And what is being asked here? An offset slider crank mechanism in this figure at any instant is shown. What will be the quick return ratio? Find out kariye what is going to be the quick return ratio. They may also ask what is going to be stroke. They may also ask stroke. Find out kariye. Another question. Getting a point? And how do we solve these kind of questions? How do we solve these kind of questions? बहुत ध्यान से देखो, multiple times I have told all of you that quick return, a question which belongs to quick return motion mechanism, is not a question of theory of machine. It is a question of geometry. If you can draw extreme positions, you can very easily solve this question, beta. Very easily. Offset slider crank mechanism they have given. Let me draw this. In a new page, let me draw this. Diagram is something like this. Offset they have provided in downward direction. Mechanism is somewhere here. This is the crank. 30 mm ka crank they have given, and 70 mm ka they have given as connecting rod. This is the connecting rod. Let me draw connecting rod. This is the connecting rod. This is the fixed point about which crank is going to have rotation. Dimensions they have given. This dimension is given as how much, beta? 30 mm. This crank connecting rod is given as 70 mm. Those who don't know how to solve this problem, please look carefully, because examination may you may expect questions from here. Question is given something like this. Acha. First, let's draw. Cutter is somewhere here. Can I say? Acha. How they have connected motor? They have also given the direction of motor. Motor is connected in clockwise sense. Okay. But hey, the orientation of the cutter they have shown, and motor is also given. Now be very, very careful. Everything they have given. So what is going to be cutting stroke angle? What is going to be return stroke wala angle? That is going to be fixed. They have already given all these things. Now you cannot do this thing ki bhai larger angle ko we can take it as cutting stroke angle and smaller angle is going to be return wala. No. Everything they have given. Cutter ka orientation is given. Motor ka direction is given. So at this time, you have to check whether larger angle is cutting stroke angle or smaller angle is cutting stroke angle. Everything is given. Let's draw the extreme position. Acha, in this case, extreme positions are going to be where? This slider is going to have reciprocating motion in this line. And the slider ka one extreme position will be, slider will be somewhere here when crank and connecting rod are going to be in line, 180 degree wala in line. What I am trying to say is when crank and then this is your connecting rod. This is going to be your one extreme portion of the slider. Getting my point? First thing. Second thing, another situation. Sir, when this crank and connecting rod, again, this is your crank or 0 degree pe you are going to have something like this. These two positions are going to be the extreme positions. For the slider's extreme position, how crank and connecting rod are going to look. This is the diagram. Getting my point? Now, if you can understand this thing very, very carefully, we can draw it very easily, beta. Very easily we can draw the diagram. Draw kar lijiye. Draw kar lijiye. Something like this. We have drawn a diagram somewhere here. Sir, when crank and connecting rod are in line, 180 degree wala in line, outermost position, where? Sir, this is the crank. And in line to this, you are going to have your connecting rod. Something like this. You will have situation like this. Getting my point? This I have shown my crank and 180 degree in line I have shown my connecting rod. Can I write this? One extreme position. Second extreme position mein crank and connecting rod are going to make 0 degree angle between them. Again they are going to be in line. Let me draw that with some different color. Sir, it will look something like this. It will look something like this. Where is the crank? Sir, crank is this. And in line to this, we have drawn this connecting rod. Getting my point? I hope everybody is clear. I hope everybody is clear. So these are the two diagrams which I have drawn. Two positions I have drawn. Okay, na? For one position, cutter will be here. Another position, cutter will be here. And between these two positions, your cutter is going to have reciprocating motion. This is something which I am going to call it as a stroke. Clear, beta? This is something which I am going to call it as a stroke. Let me copy this diagram. Very, very careful. Very, very careful. Acha, if I take few things outside, take this portion, this triangle. Can you see this triangle? Take this triangle outside and another triangle. This one. These two triangles take outside. Acha, let me tell you first what is the quick return ratio here. Beta. What is the forward stroke? Cutting stroke here. Sir, let me give it some name. This is point A. This is point B. And this is your point C. When C is at C1, point B was somewhere here at B1 position. When point B has reached to this position, point B2, can I write? Point C will reach somewhere here at C2. And from C1 to C2, I can say you are going to have your cutting stroke. From C1 to C2, C1, C2, we are going to have your cutting stroke. Acha, my dear students, can you tell if cutter is moving from C1 to C2, that means corresponding point B will move from B1 to B2, and B1 to B2, how you are going to move? You don't have any choice. Motor already is given. B1, from B1 position, crank will be here. For B2 position, crank will be here. And how you are moving from B1 to B2? Clockwise or anti-clockwise? But a motor is given as clockwise. If motor is given as clockwise, that means from here, this is something which you are going to call it as cutting stroke angle. बात समझ में आ रही है? Getting a point? C1 to C2 is going to be your cutting stroke. That means for cutting B1 to B2 and motor, how this motor is going to be there? Sir, motor is from B1 position to this B2 position. This is going to be your cutting stroke angle. This is going to be your cutting stroke angle. And C2 to C1 return, यानी कि B2 से B1, you are going to have your return stroke angle. This is going to be your alpha. And everybody, even a blind person, can tell that here, sir, something is wrong. Something is wrong. In this diagram, it seems that cutting stroke angle beta is smaller than alpha. Sir, beta is smaller than alpha. Although, if somebody is asking what is going to be the quick return ratio, it is always defined as cutting stroke angle. Cutting stroke angle divided by return stroke angle. Getting a point? This beta by alpha, and this beta by alpha ka value, quick return ratio, beta by alpha, sir, this is going to be less than 1. This is actually a wrong diagram. Whenever you talk about quick return motion mechanism, we have to design things in such a manner, we have to connect motor in such a manner that quick return ratio comes out to be more than 1. But this is not more than 1. That means something is fishy. Motor ka direction is wrong here. But you have to give your answer according to this. Getting a point? Some people are giving me answer 0.907. Great. Great. Clear hai? Clear hai? Acha. I hope people have, captured the key which can give you some, positive marks or where you can commit mistake. Okay. Further, how do we solve this? Everybody knows. Very easy. If this angle is delta, this small angle is delta. So can I write this angle beta ko you can write it as 180 minus delta. लिख सकते हैं क्या? This beta can be written as 180 minus delta divided by alpha ko you can write it as 180 plus delta. 180 plus delta. Somehow you can calculate delta and then you can easily find out quick return ratio. लिख सकते हैं? And how do we calculate this? कैसे लिखेंगे? This is the eccentricity. This is the center of rotation of the crank. One position is given. This green color wala line I am drawing. Very, very careful. This green color wala line I am drawing. Eccentricity already I have drawn. Green color wala line. How much will be this line, beta? This line can be written as R plus L. कितना हो जाएगा? This line is going to be R plus L. And how much is the value of R plus L? This is R plus L. R ka value is given as 30. L ka value is given as 70. Let me check. 30 and 70. ठीक है बेटा. R plus L is given as 100 mm. And again, I will be drawing this line. From this wala line. How much is this line, beta? What is the length of this line? Sir, from this point C1 to this B1, this is length L. And from A to B1, this is R. So can I write this much portion will be L minus R? लिख सकते हैं क्या? लिख सकते हैं क्या? Sir, this is your L minus R. And how much is the value of L minus R, beta? L minus R is going to be 40. Clear hai? One position, another position. This is C1 position, this is C2 position, and this is going to be your stroke. S से denote कर रहे हैं. This is something which is your angle delta. This is angle 90 degree. Very easily you can calculate all these things. Somehow you can calculate a stroke. स्ट्रोक को क्या लिखा जा सकता है? वी कैन राइट स्ट्रोक इट एज, स्ट्रोक कैन बी रिटन एज, eccentricity is given as how much beta? Eccentricity is given as 10 mm. 10 mm. This is given as 10 mm. Careful, careful, careful. So this big value minus this small value. Big value कितना हो जाएगा? This is going to be 100 square minus 10 square. 100 square minus का 10 square under root के अंदर minus this small value is how much beta? 40 square minus 10 square. 40 square minus का 10 square under root. Somebody please tell me how much is the value of a stroke. And once you calculate the stroke ka value, you have calculated how much is the stroke. Stroke ka value is known. Using cosine rule, you can find out, you know, this is a diagram, triangle. All three dimensions, this is 100, this is 40, this is something which you have just calculated. Very easily you can calculate how much is the value of delta. Delta ka value kitna ho jayega? Somebody please tell me what is the value of stroke coming out to be. Rohit Rajput, I will answer every doubt. But please first let me know how much is going to be the stroke ka value. Kitna aa raha hai? This is 100 square minus 10 square. Whatever is there, under root le lijiye. 99.49. This comes out to be 99.4987. How much is this value? 40 square minus 10 square. Whatever is coming, under root कर लीजिए. 38.72. 38.7298. Subtract minus 99.4987. This value is coming out to be 60.7688 mm. Clear है बेटा? I will answer all your questions. Don't worry beta. Pehle let me solve this question, and then whatever you will say, sir, eccentricity, if it will be above, what is going to be the change? If motor ka direction is going to be reversed, what will be the change? I will discuss everything. Don't worry, just don't worry. Stroke ka value you have already calculated. This delta ka value we can calculate. Can I write? From cosine rule. Cosine rule. I hope you must know the cosine rule. Arey beta, a triangle is given. This is side A, this is side B, and this is side C. Side B, opposite angle is angle B. Side A, opposite angle, this angle is given as angle A. And this is side C, opposite angle is given as angle C. So can I write angle A if you have to write? So cosine of angle A, cos A can be written as B square plus C square minus opposite wala side square. B square plus C square minus A square divided by twice of these adjacent sides, twice of BC can be written. It can be written like this. Getting your mind? If you know all these three dimensions, angle delta can be easily find out. How much is going to be cos delta beta? Cos delta can be written as 40 square plus 100 square minus whatever is the stroke square. Kitna hai? How much is the stroke? 60.7688 square divided by twice of 40 into 100. You will get something delta. And once you get delta, delta का value कितना आ रहा है बेटा? Somebody please tell me. Delta का value कितना आ रहा है? 40 square plus 100 square minus 60.7688 square. Whatever you have got divided by 2 into 4000. 0.988. And cos inverse, take cos inverse of this 8.7377. 8.7377 degree. This is the delta ka value. And once you know the delta ka value, quick return ratio can be very easily calculated. How much is going to be quick return ratio? Quick return ratio. Here it is 180 minus delta. Kitna ho jayega? This is coming out to be 180 minus 8.7377 divided by 180 plus 8.7377. Please let me know the answer. This is coming out to be 171.26229 divided by 180 plus 8.7377. 188 point something. 188.7377. Okay. 171.269 divided by answer करिए 0.9074. So quick return ratio is coming out to be how much beta? 0.9074. Clear है बेटे? This is going to be your answer. Now, question. This question, have you understood or not? I will change the question accordingly. Whatever you are saying, I will do all the modifications. But first, let me know in the chat box. This question is clear to everybody. How we have calculated here. This is clear to everyone. Please let me know in the chat box. Please let me know in the chat box. All good? Okay. Now, some student is saying, sir, what if students are saying, what if this motor is not given? Everything is given, motor is not given. But again, if motor is not given, same question. If motor ka direction they have not given, if motor ka direction they have not given, so just by looking at this diagram, at least cutter ka orientation they have given now. So this thing is fixed. If whenever cutting stroke is going to be there, cutting stroke will be in this direction. This is going to be your cutting stroke. And what is the return? Sir, in this direction you are going to have return stroke. This thing is fixed. No change in this. Now, extreme position. What will be the extreme position, sir? Extreme position, again, we have just learned. Extreme positions are always going to be there when crank and connecting rod are going to be when crank and connecting rod are going to be collinear. 0 degree वाला collinear and 180 degree वाला collinear. बात समझ में आ रही है? That means one extreme position you will get when crank is this, and just in front of this we are having your connecting rod. Yani ki one extreme position is fixed. One extreme position we have got somewhere here. One extreme position. Let me write, this is point A, this is point B, and this is point C. So when this point C is somewhere here, extreme position you have got. Another extreme position, ये 180 degree वाला angle I have made. Another extreme position, that will be again same. Sir, exactly same. Crank connecting rod is this. This is your connecting rod. And where is the crank? Sir, crank is making 0 degree wala angle. Very close I have made this. Very close I have made this. Let me zoom this diagram a little bit so that you can feel it. Beta, very careful. This is the crank. Crank ka position is here. This is your point B. And then this is your connecting rod. Just for the sake of clarity, I have made these two lines different. Just for the sake of clarity. Otherwise, these two things are exactly coinciding with each other, beta. Exactly coinciding. Getting my point? ठीक है? Extreme position is not going to change. Never. When this point B will be at B1, point C will be, this cutter ka location is going to be at C1 position. And when this point B has moved to this B2 position, your point C will be at C2 position. So can I say C1 se C2 ko, C1 se C2. This is your cutting wala position, cutting wala stroke. C1 se C2 cutting hai. It means C2 se C1 you are going to have return. And C1 se C2 cutting hai. It means B1 se B2 you are going to have cutting stroke. When your crank will move from B1 to B2. A B1 motor is not given. Motor they have not given. Generally, by default, if motor is not given, so by default, quick return ratio is going to be more than 1. We know this. You will take larger angle as your cutting stroke angle. If motor is not given, motor is not given, you have choice. Either you want to go in clockwise sense or from B1 position to B2 position in anti-clockwise sense. So, sir, I will choose my larger angle as my cutting stroke. So, B1 se B2, I will go in such a sense that I will cover larger angle. This is going to be my beta. So, obvious सी बात है, rest of the angle, this is going to be your return stroke angle alpha. बात समझ में आ रही है? So if motor is not given, by default you will choose quick return ratio to be more than 1, larger angle as cutting stroke वाला angle. नंबर एक चीज. दूसरा, if they have given कि भैया motor is in, this is the motor, I'm happy, no problem. है ना? Anti-clockwise, I wanted it to be anti-clockwise. Somebody is saying कि sir, what if eccentricity diagram everybody can understand. Somebody is saying, sir, what if this eccentricity which you have given here, if it is not in downward direction, if it is in upward direction, doesn't make any sense, doesn't make any change. Now, beta, for me, it doesn't make any change. कैसे कह रहे हैं? Let me show you that. Careful. I will just show you how to make extreme positions. That's it. Just try to capture the concept. Once you can feel the concept, examination mein whether they are going to change eccentricity ka direction below or above, motor ka direction, clockwise or anti-clockwise, every question you can solve it. Here I have connected my crank. This is my crank. And connecting rod is somewhere here. And eccentricity this time they have given in upward sense. No issue. कोई problem नहीं. Something like this they have given. Where is the eccentricity? Sir, eccentricity, this value is eccentricity. ठीक है ना? Where is the slider? Cutter कहाँ है? Sir, cutter is somewhere here. Always, quick return motion mechanism का question is asked. Always you have to do one thing. You have to draw first of all extreme positions. That's it. Draw कर लीजिए बेटा. Draw करिए. This crank is going to have rotation on this circular path. Okay, I can understand. Very well, I can understand. Extreme positions. Where are going to be the extreme positions? Always when crank and connecting rod are going to be in line. 0 degree in line, 180 degree वाला in line. बनाइए बेटा. 0 degree वाला in line. 180 degree वाला in line. Where is going to be that? Sir, crank is somewhere here. This is your crank. And in line to this, we are having connecting rod. One position I have drawn. Or to make it a little bit clear, let me. Just for the sake of clarity. Let me make this eccentricity a little bit big. So that you can watch it clearly. Okay, na? This is the cutter which I have shown here. Extreme positions. Where are going to be the extreme positions, sir? When crank and then connecting rod are going to be in line. One position I have drawn. Okay, na? Again, let me write some name. This is point A, this is your point B. When B has reached to this B1 position, your cutter, which is C, it will reach at C1 position. Another extreme position. This is the farmost, outermost position. And another extreme position, where you are going to get that? Sir, another extreme position will be when your connecting rod and crank are having 0 degree in line. 0 degree in line का मतलब क्या होता है? Sir, this is your connecting rod. And crank is somewhere here. This is your crank. In line to this. ठीक है ना? This is B2 position. Corresponding to B2 position, your cutter is at C2 position. Now you can decide from C2 to C1. This is something which you are calling as cutting stroke. Check कर लीजिए. C2 to C1 you are calling it as cutting stroke. That means from B2 to B1, a motor का direction you have not given. You have to decide clockwise or anti-clockwise. So C2 to C1 cutting, I want cutting stroke angle to be larger. So B2 to B1, you will travel in such a manner that B2 to B1, you are traveling larger angle. So you are going to travel in clockwise sense. This is going to be your beta. Motor, you are going to connect in clockwise direction. Everybody is clear or not? Please let me know in the chat box. Everybody is clear. Doesn't matter whether they have given eccentricity in upside direction or in downward direction. Doesn't matter at all. If you know how to make diagram, you can solve any question very easily. Clear hai beta? Shall we proceed to the next question beta? यहां पर बातें समझ में आ रही हैं? Everybody is comfortable? ठीक है? चलो. Another question. And whatever I have done for offset slider crank mechanism, exactly same things you have to do. You have to perform for whether it is Whitworth quick return motion mechanism or crank and slotted quick return motion mechanism. Always you have to draw extreme positions. Draw the extreme position, draw the geometry in front of you. If you have the clear diagram, whatever they are asking, stroke, quick return ratio, everything you can calculate. ठीक है ना? चलो. Let's have a look at the next question. Acceleration diagram se related question is there, and what they are asking. Figure shows a slider. Moving outwards on rod with velocity of 5 meters per second. What things they have given? Let me check. Figure mein they have given a fixed link is there. Then we have a rotating link on that. There is a link which is rotating. And on that rotating link, we are going to have a slider. This slider is sliding radially outward direction with 5 meters per second velocity. ठीक है ना? Let's read out the question first. Figure shows a slider moving outward on rod with a velocity of 5 meters per second. Outward direction में direction is given. When its distance from point O, यानी कि from point of rotation, its distance is given as 2 meters. At this instant, the velocity of slider increases at a rate of 12 meters per second. 12 meters per second square. This slider is not just moving with constant velocity. This slider is also having some acceleration in this direction. In the direction of sliding velocity, this slider is also having some acceleration. So at this instant, its velocity is given as 5 meters per second. Next moment, its velocity is going to change something else. Next moment, its velocity is going to change something else. Velocity is going to increase continuously. Getting a point? So slider ka velocity they have given, and slider ka in the direction of sliding, how much is the acceleration? That is also given. 12 meters per second square. Okay. Rod has an angular velocity of 8 radian per second counterclockwise. Angular velocity counterclockwise direction they have given about point O, and angular acceleration is also there. Oh ho ho, everything they have given. Generally we are habitual कि भाई examination में they will give angular velocity so that radial acceleration can be calculated. Alpha is given, tangential acceleration can be calculated, and if in picture Coriolis acceleration is coming, so we will calculate Coriolis acceleration, and then resultant we know how to calculate that. But gate examination mein they are very very smart. They will twist the question. You will read you will learn up to certain step कि भैया up to this 90th step we have completed the syllabus. Examination mein question they are going to ask at 91st level, just one step ahead. And how you can solve this? If you have understood the concepts thoroughly, not just mugging up the formulas, not just fitting values in the formulas. You have to understand the concept. Then only you can try and solve new kind of questions. Let's try to solve this question. What they are asking, the absolute acceleration of this slider bataiye, how much is going to be this? Absolute acceleration. How can we calculate? Let me draw the diagram carefully. Something like this they have given. Question mein, this is the point about which link is going to have rotation. This is the link which is having rotation. Okay. Acha, on rotating link, slider is there. So whatever rotations they related, whatever accelerations are there, those acceleration this slider is going to face. कौन से acceleration हो जाएंगे बेटे? One acceleration is going to be there, which is radial acceleration. And what is the formula of radial acceleration, beta? सर रेडियल एक्सेलरेशन होता है r ओमेगा स्क्वायर. मतलब from this center, whatever is the radial position, can I write this radial position is given as 2 meter. So how much is going to be this radial acceleration? R की value is given as 2. Omega is given as how much? Omega is given as 8 radian per second. 8 square. How much is going to be this? R omega square कितना हो जाएगा? R into omega square. 128. 128 meter per second square. Okay. What will be the direction, beta? What will be the direction, sir? Radial acceleration always it is going to act towards the center. Always it is going to act towards the center. Always something like this. Radial acceleration. And then we are going to have tangential acceleration. How do we write tangential acceleration, bete? Sir, tangential acceleration can be written as r alpha. What is the value? R ka value is given as 2. Alpha ka value is given as how much? 24 radian per second square. So r alpha ki value kitni ho jayegi? This is 48 meter per second square. And what will be the direction, beta? Its direction. Sir, alpha is given as clockwise. So perpendicular to the link in downward direction, you are going to have tangential acceleration. Let me draw that diagram. Tangential acceleration is going to be somewhere here. This is 48. Tangential acceleration. ठीक है भाई. Coriolis acceleration will also be there, na? Coriolis acceleration will also be there. How much will be? How much will it be? Twice of velocity into omega. Velocity of sliding and angular velocity of the link on which slider is sliding. What are the values they have given? क्या values दे रखी हैं? Velocity is given as 5 meter per second. From the value 2 into velocity is given as how much? But 5 meter per second. Omega is how much? Omega is given as 8. कितना हो जाएगा? This is coming out to be 80 meter per second square. And how you can find out its direction? Everybody knows how to find out direction of Coriolis acceleration. Beta, to find out the direction of Coriolis acceleration, you have to take the direction of velocity. This is velocity. Velocity is given this, na? This is the velocity 5 meter per second. Rotate this velocity in the sense of omega. Sense of omega means omega is anti-clockwise, na? So anti-clockwise you have to rotate this. About tail we are going to rotate. Anti-clockwise rotation का मतलब होता है this is anti-clockwise in the sense of omega. Where you will reach at this 90 degrees rotate किया, you will reach here. This is something which is Coriolis acceleration. Let me draw that. Coriolis acceleration is somewhere here. Coriolis acceleration. And one acceleration is already given 12 meter per second square in the direction of sliding velocity. That also you have to calculate. This is something which is new, which we are not generally habitual of. ठीक है ना? This 12 meter per second square, this is already given. 12 meter per second square, this is also already given. So there are these 4 accelerations which are going to act, and now you have to calculate the absolute acceleration resultant. Find out कर लीजिए बेटे. Is this clear to everybody? Tell me how much is the total absolute acceleration. How much is the total absolute acceleration बेटे? कैसे निकालेंगे? Absolute acceleration, total acceleration can be written as Coriolis and tangential, they will be added or subtracted algebraically. कितना हो जाएगा? This Coriolis minus tangential square plus this 12 and radial acceleration, they will be subtracted or added because they are in collinear, na? So these vectors are going to be added or subtracted algebraically. कितना हो जाएगा? This radial acceleration minus 12 square under root. This is how you can calculate. Coriolis minus tangential, how much is this, beta? Coriolis minus tangential, 80 minus 48. 80 minus 48, 32 square plus in which direction? Coriolis minus tangential. Coriolis कितना था बेटे? 80. Tangential was 48. So y direction में resultant acceleration is somewhere here. And x direction में acceleration is going to be where? Radial minus 12 करेंगे, you will get 128 minus 12. 128 minus 12. This is 116 in this direction. 116 and this is 32. So resultant will be somewhere here. Getting my point? 116 square. 32 square plus 116 square under root ले लीजिए. You will get how much is the total acceleration? But I am getting answer 120.3328 meter per second square. Everybody is clear or not? Everybody is clear or not? Please let me know in the chat box. Total acceleration they have asked, and this is the total acceleration. Bete 120.33. Okay, if somebody is asking what will be the direction, very easily you can tell what is going to be the direction. From this link, it is making some angle. This angle very easily can be find out. Anybody please tell me how much is the angle? Direction, they may also ask what is the direction of total absolute acceleration. So sir, total absolute acceleration, direction is going to be somewhere here. This is absolute acceleration, total acceleration. At what angle? This angle very easily can be calculated. This angle theta we can calculate very easily. कितना हो जाएगा this angle? This angle can be written as sir tan theta is equal to y component divided by 116. कितना हो जाएगा? 32 divided by 116. Tan inverse 15.42. Theta is 15.42 degree. Everybody clear? How much is this angle? This theta is 15 point something. 15.42 degree. Examination में these kind of questions can definitely be asked, beta. Clear है? देखो, again, I'm trying to keep this session as crisp, as short as possible, while covering all the important formulas, all the important concepts where chances of getting question is going to be very, very high. Okay? So from mechanism, again I am repeating, from mechanism, there are very, very important portions like mechanism ka degree of freedom, Grashoff's law, and all three varieties of quick return motion mechanism. These three things are very, very important. After gate examination, we will come back again and we will talk directly. And you will definitely say, sir, from this session, we have got few questions directly in our examination. Clear, bete? Next, we are going to talk about gear and gear train. Acha, gear and gear train mein what kind of questions they are going to ask? What kind of questions they are going to ask? Sabse pehle, they are going to ask questions which are based upon minimum number of teeth. They will ask, calculate minimum number of teeth. ठीक है ना? They will ask minimum number of teeth. For what? So that interference can be avoided. ठीक है ना? So we have some direct formulas. Small t minimum का formula we have, capital T minimum का formula we have. Based upon these two, you have to give your answers. Twice of AP divided by under root के अंदर very big things. 1 plus G plus 2 sin square phi under root के outside -1. If we are talking about capital T minimum, this is going to be twice of AG divided by under root के अंदर we are going to have 1 upon G plus 2 sin square phi -1. These two formulas you are going to use. Achha, while using these formulas, you have to be a little bit cautious. Why I am saying this? You will get some answers from here. If this is coming out to be in complete digits mein, I'm okay. No problem at all. But if this answer is coming out to be 15.2 teeth you have to provide, so you have to go to this next integer. Sir, 16 teeth we are going to use. बात समझ में आ रही है? But before saying, sir, 16 teeth on pinion you have calculated. Here maybe you will calculate some number of teeth. But before saying, here also you have calculated some number of teeth. Sir, 48 teeth. But before saying that this is your answer, please check, please ensure that minimum number of teeth 16 on pinion, interference will not happen on the gear. These many teeth on pinion you should provide so that it is not doing any interference on the gear. These many teeth on gear you should provide so that it is not doing any interference on the pinion. So if you are providing these many number of teeth, so interference is not happening. But you have to check before saying that this 16 teeth wala pinion and 48 teeth wala gear we are going to use. Before claiming that, you must ensure that these two pairs are providing you the required gear ratio or not? Getting my point? So 16 and 48 check kar lijiyega whether gear ratio wala condition is satisfied or not. I will give some question. Second type of question they are going to ask. Second type of question on the gear train they can ask. Acha, gears में minimum number of teeth पे questions can be framed. Sometimes they may also frame questions based upon all other portion like path of contact. Calculate करिए. What is the arc of contact? They may ask to calculate arc of contact. Some big formulas you are going to have. You must remember these formulas. They may also ask what is going to be the contact ratio. ठीक है ना? They may also ask if center distance is increased by certain amount, pressure angle changes. We know this. So how much is going to be change in that pressure angle? How much is going to be the new pressure angle if center distance is altered a little bit? So these are the things from where questions can be framed. ठीक है ना? Second important thing is going to be from gear train, and from gear train they will ask questions. Generally, most of the chances are that you will get a question from epicyclic gear train. Epicyclic gear train. Most of the chances are there that first question from gear train, if there is one question on gear train, that will be from epicyclic gear train. The second priority, the second chance is there that you may get a question from compound gear train. Compound gear train, or you may get from even reverted gear train. Clear hai na? And how do we solve questions with the help of how do we solve these type of questions? I will tell you in the further coming questions. Let's have a look. सबसे पहले, the very first question they have asked, a 20-degree pressure angle, 11 tooth pinion, 20-degree pressure angle they have given. Achha, this pressure angle, everybody must know that whenever we are saying we are using a pair, so for a given pair, module must be same, pressure angle for pinion and gear it must be same, circular pitch must be same. These things must be same for pair. Pinion as well as gear, both are going to have same module, same pressure angle, same circular pitch. Everybody knows this. So they have given pressure angle how much? 20 degree bete. 20 degree pressure angle is given. 11 tooth pinion is going to drive 22 teeth gear. So teeth they have given. Small t, how much they have given? 11 tooth. Capital T, gear mein tooth, they have given 22 teeth. Okay, great. The gears have module of 4 mm. Whose module is given? Sir, this is the module of both pinion as well as gear. 4 mm module is given. Great. Module is given as 4 mm. Both gears have standard involute stub teeth. And what is the meaning of this standard involute stub teeth? Bhai, whenever they say if they must give stubbing they have done here. So how much stubbing they have done? They must write this. If they have not written, they have clearly said standard stubbing we have done. So whenever we do standard stubbing, standard full depth involute if you are providing, so addendum is going to be equal to module. If standard stubbing you have done, so how much is going to be this fractional addendum? This is going to be 0.8 times. बात समझ में आ रही है? 20% stubbing you are going to do. बात समझ में आ रही है? So this language is going to play a very important role. Standard means जो fractional addendum, standard stubbing कर रखी है ना, so fractional addendum of pinion 0.8 is going to be there. For gear, they have mentioned both gears have standard stubbing. यानी कि pinion में भी they have provided 0.8 fractional addendum, and for gear also they have given AG ka value is also given as 0.8. Getting my point? This value, how I am writing? Because these are the standard data. Everybody must know this. Everybody must know this. Clear hai? Which of the following statements are correct? This is the MSQ bete. More than one options are correct. More than one options are going to be correct. क्या क्या पूछा है? दे आर आस्किंग वेलोसिटी ऑफ स्लाइडिंग विल बी मैक्सिमम एट द एंड ऑफ एंगेजमेंट. ओके. अच्छा, velocity of sliding. First of all, let me write few things. Velocity of sliding. अच्छा, data. Let me write some data. AP AG. This is given as 0.8. First of all, first thing they have asked, velocity of sliding के बारे में बताओ. What is the velocity of sliding बेटे? Everybody knows velocity of sliding होता है contact point का pitch point से whatever the distance multiplied by relative velocities, relative angular velocity omega 1 with respect to 2. ऐसे लिख रहे हैं. अब omega 1 with respect to 2, how you have to write? And omega 1 with respect to 2, it is always written as omega 1 minus omega 2. With the sign you have to put down the values. With the sign you have to put down the values. Means what I'm trying to say is, if you are having external meshing, बहुत ध्यान से, careful, careful, careful. If you are having external meshing, can I say one gear is going to rotate, omega 1 is going to be in clockwise direction, so omega 2 will be in anti-clockwise direction. Clockwise, and this is going to be in anti-clockwise direction. Can I write clockwise को if you are saying as positive, anti-clockwise क्या हो जाएगा? This is going to be negative. Put down the value. This is suppose this is plus 10 radian per second. So this is going to be minus का something 5 radian per second. With the sign you have to put down the values. Omega 1 minus omega 2. Sir, if both these gears are rotating in opposite direction, so omega 1 ka value you have put plus 10 minus omega 2 ka value minus 5. So these two numbers are going to be added. This is 15. And this 15 value you have to put it here. What if these two gears are going to rotate in same direction? Arey bhai, internal meshing is happening. In that case, if one gear is rotating clockwise 10 rpm se, 10 radian per second se, so other gear is also going to rotate in the same sense, internal gearing mein, same sense. Direction is not going to change. बात समझ में आ रही है? So this is plus 10, this will be, plus 5. Things will be subtracted. Keep this thing in mind. अच्छा, velocity of sliding. देखो, gears का omega 1, omega 2 is not going to change. Omega 1 and omega 2. If one gear is rotating at 100 rpm, other gear is rotating at 200 rpm. So during entire journey, these velocities are not going to change. Omega 1, omega 2 and relative velocities, this is going to remain constant. Contact point is going to vary. So when contact point, pitch point say, is at the largest distance, we are going to have maximum sliding velocity. Can I write? And how this contact point looks, let's have a look better. This I have drawn my pinion, chotu sa small pinion I have drawn, and this is your gear bete. This is the big size gear. This is your big size gear. This is the common tangent which I have drawn at pitch point. Where is the pitch point P? Sir, pitch point is somewhere here. This is your pitch point. This is the pitch point. Line of action. Where is the line of action? Beta, line of action is somewhere here. Let me draw this with some red line. Diagram is clear to everybody? This is line of action beta. Pinion is going to apply force in this direction. यही तो होता है एंगल फाई. दिस एंगल इज गोइंग टू बी योर एंगल फाई. प्रेशर एंगल बेटा. अच्छा, draw a perpendicular. This is the radius of base circle of pinion. Draw a perpendicular here. This is going to be radius of base circle of gear. And यही तो होते हैं points. This is point M. We used to call it as point M, and this is point N. Interference point. Remember? Interference point, critical point. Contact point. We used to find the contact point somewhere starting at here. From point K, contact will start, and contact point will keep on traveling, passing through pitch point, and somewhere here at point L, contact will end, disengagement will happen. So contact point, where you can find the contact point, sir? Contact point will be somewhere at K. Slowly it will reach towards point P, and then again moving away from point P, and at L it will disengage. Both these teeth will disengage. बात समझ में आ रही है? So contact point का distance, max to max distance from pitch point, where it can be, sir, either at point K at the start of engagement or at the end of engagement. Calculate कर लीजिए. Either point, when point Q, contact point Q is at K, so from this point to pitch point का distance, either this is going to be used as largest distance, or from point P to this value, this is going to be used as the largest distance. I don't know. You have to calculate. You have to calculate. Getting a point? So one thing is clear. Either at the start of engagement, sliding velocity is maximum, or at the end of engagement, sliding velocity is maximum. Calculate करिए KP का वैल्यू कितना है and PL का वैल्यू कितना है. How much is KP? KP and PL. This is something which is called as path of approach, and this is something which is called as path of recess. This is path of recess. KP का formula होता है, this KP standard general formulas are there, and I never recommend anybody to remember these formulas. If you can draw the diagram very easily, I don't recommend anyone to remember these formulas. Suppose examination mein you have forgot the formula. Careful. Can I write from here? This value is what? This is RA, radius of addendum circle of gear. ठीक है ना? What is this value? This is capital R, radius of pitch circle of gear. This angle is phi. This angle will also be phi. तो ये कितना हो जाएगा? This is R cos phi. And how much is this value? But this value, this is going to be R sin phi. Let me write. This is going to be R sin phi. So can I very easily write? KP का वैल्यू लिखना है ना? We have to write KP का वैल्यू. KP का वैल्यू can I write? From this triangle. Look at this triangle. Right angle triangle है ना? So this value can be written as RA square minus R cos phi का square under root. You have got this value, and from this value subtract कर दीजिए this small value R sin phi. You will get KP का value. कितना हो जाएगा KP का value? This KP का value can be written as, आ गया formula, under root RA square minus R cos phi square minus R sin phi. That's it. Clear है? Some people have already got the answer. Similarly, PL का value, whatever values you have written in terms of capital R, it will be in terms of small r, under root RA square minus R cos phi square minus R sin phi. That's it. Put down all these values. Small r, small ra, capital RA, all these values they have given here. All these values they have given here. Measure कर लीजिए बेटा. How do we measure these values? Sir, this data they have given in the question. Module पता है. Number of teeth they have given. Can you find out pinion pitch circle का radius? Can I write? Small r is equal to m by 2. Small t by 2. Module कितना है बेटा? Module is 4 mm. 4 mm. Small t is how much? 11 teeth. Divided by 2. कितना हो जाएगा? This is coming out to be 22 mm. Small r पता चल गया? और small r plus addendum. Small r plus addendum. यही तो होता है. This is small ra. Small r is how much? This is 22 mm. Plus how much is the addendum? Fractional addendum times module. Addendum का value is how much? Let me write. Addendum का value होता है fractional addendum times module. Put down this value. कितना हो जाएगा? Fractional addendum is given as 0.8. Module is how much beta? 4. This value is coming out to be 3.220. कितना हो जाएगा? 0.8 into 4 plus 22. This is 25.2. Small RA. Similarly, you can calculate capital R and capital RA. निकाल लीजिए बेटे. Capital R is how much? Capital R will be equal to how much? Capital R का value हो जाएगा. This is coming out to be M capital T by 2. M is 4. Capital T is how much बेटा? 22 divided by 2. कितना हो जाएगा? This is coming out to be 44 mm. Capital RA कितना हो जाएगा? This is again capital R plus whatever is addendum. 44 plus 3.2 कितना हो जाएगा? This is 47.2 mm. All these values, just put down the value, you will get some answer. कितना आ रहा है बेटा? Just put down all these values. KP and PL का value, you will get something. कितना आ रहा है? Somebody is giving me answer. KP is coming out to be 7.7175. 7.7175 mm. Please check once whether these are correct or not. PL का value, how much? People are saying PL का value is coming out to be 6.885. 6.885 mm. Let me check one value. Capital RA 47.5 square minus capital R कितना है बेटा? This is 44 cos 20 square. Whatever you have got, under root minus 44 sin 20. This is coming out to be, अरे यार 8 point something आ रहा है. You are saying 7.71, but I am getting ऐसा कैसे बेटा? ऐसा कैसे? Please check. Calculation में you shouldn't do any mistake. अरे भाई calculation में there should not be any mistake. There should not be any mistake. Check करिए. Once again, please check बेटा. This data is not correct. This data doesn't seem to be correct. This data doesn't seem to be correct. RA का value is 47.2. अरे sorry. My mistake. This is 47.2. I have taken as 0.5. 47.2 square minus R का value is 44 cos 20 square minus 44 sin 20. Let me check. 47.2 square minus 44 cos 20 square. Whatever you have got, under root 22 point. This value is coming out to be 22.7664 minus 44 sin 20 7.7175. ठीक है बेटा, correct. My mistake. ठीक है, this value is correct. ठीक है, similarly you will get something here. Small RA का value is how much बेटा? Let me check. Small RA का value is 25.2. 25.2 square minus का 22 cos 20 square under root minus 22 sin 20 degree. Let me check once again. 25.2 square करेंगे minus 22 cos 20 square, take out under root minus 22 sin 20 6.8858. ठीक है बेटा, correct. I am unnecessarily doing doubt on you. You are intelligent. You are intelligent. Correct, beta? Path of approach and path of recess. Now check kariye. It seems path of approach is larger. Path of approach, KP ka value is larger than PL. Path of approach is larger. So sliding velocity is going to be maximum where? At the start of engagement. Which option is correct? KP and PL का value. KP का value is 7.7175. PL का value 6.8858. At the start of engagement, velocity is going to be, sliding velocity is going to be maximum. They are saying velocity of sliding will be maximum at the end of engagement. Na bhaiya na, not at end. At the start it will be maximum. This is wrong. Option D, they are saying path of approach is greater than path of recess. Is it correct? KP ka value, they are saying KP ka value is more than PL. Is it true or not? Yes, sir, this is true. This is absolutely true. Option D is correct. Then they have asked contact ratio batao. An arc of contact is going to be how much? Try kariye. If you know path of approach, path of recess, तो path of contact कितना हो जाएगा? Path of contact, which is KP plus PL. How much will be this? KP plus PL कितना हो जाएगा? This is coming out to be 7.7175 plus 6.8858. 14.60. This is 14.6033 mm. This is path of contact. So what will be arc of contact, bete? Path of contact, KL divided by cos phi divided by cos 20. This value is coming out to be 15.54. 15.5405 mm. This is your arc of contact. Okay, na? An arc of contact, if you have calculated very easily, everybody can calculate what is going to be contact ratio. How much is the contact ratio, beta? Contact ratio is arc of contact, whatever you have got, 15.5405 divided by PC. And PC का value कितना होता है? This PC का value is pi times m. Whatever you have got divided by m, module is given as 4 mm into pi. 1.2366. This value is coming out to be 1.2366. ठीक है ना? All the answers you have got. चेक करिए. Arc of contact का value 15.54 mm. यही दिया हुआ है क्या? 15.5405. Yes, 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 correct है बेटा. Arc of contact का value same है. Contact ratio 1.23 है क्या? Yes, correct है. So which option is correct? Option B, C and D are correct. Option B, Bombay, C and D are correct. All clear, all good. ठीक है. Examination में just don't treat कि sir, अरे these formulas are very very big formulas. How can I remember these formulas? Examination में based upon these formulas, questions can be asked. And wherever you think कि sir, this formula is big, I cannot remember this formula, examiner will never ask question here. Beta, this is gate. You cannot predict anything. Gate examination में you definitely cannot predict anything. From where question can be framed, you cannot, put an idea. You cannot predict at all. So that's why I'm saying things are not difficult. Just avoid memorizing these formulas. Try to learn them. Try to feel them. How do you feel them? With the help of these diagrams. If you can understand this diagram very easily, formula directly can be framed and you can get your answers. ठीक है, आगे बढ़ें. Shall we proceed? Shall we proceed? Shall we proceed? Shall we proceed, beta? Easy question, 1 mark का question है. Shaft carries 30 tooth 3 mm module gear that drives another gear at a speed of 48 revolution per minute. Shaft carries 32 tooth 3 mm module gear that drives another gear at a speed of 48 revolution per minute. Okay. What they have given? Shaft is there, 32 teeth ka gear, 3 mm module. T1 is given how much? 30 tooth. Module is given how much? 3 mm. It is driving another gear ka speed is given as omega 2 is given as how much? 480 rpm. How fast does 30 tooth gear is going to rotate if shaft center distance is 120 mm? Careful. Exam mein what they have given? You have one gear, it is driving another gear. Okay, this is gear 1. Gear 1 is driving gear 2. Gear 1 is rotating at omega 1 speed. This is going to rotate at omega 2 speed. Omega 1, omega 2 के बारे में they have given some information कि omega 2 is 480 rpm. Number of teeth they have given here. T1 teeth, this is having T2 teeth. T1 का value they have given as 30 teeth beta. T2 they have not given. हाँ, they have mentioned center distance. Center distance they have given. They have mentioned center distance. This distance plus this distance. Can I write R1 plus R2? यही तो होता है center distance beta. For these two gears, if you know the pitch circle radius, R1 plus R2, यही तो होता है. Something which you call it as center distance. Can I write R1 plus R2? How much they have given beta? 120 mm. Okay, 120 mm. What they are asking? How fast does 30 tooth gear is going to rotate? तुमसे they are asking omega 1. Omega 2 they have given. Omega 1 they are asking. Can I write one thing? Beta, simple common sense वाली बात. Can I write one thing? Omega 1 by omega 2. It will be reciprocal of tooth T2 by T1. Or you can also write in terms of radius R2 by R1. निकाल सकते हैं. अच्छा, I think radius can be found out very easily because number of teeth they have given, module they have given. So can you calculate R1 का value? R1 होता है MT1 by 2. Module is given as 3 mm. T1 teeth is given as 30 divided by 2. कितना हो जाएगा? 45 mm. Radius R1, it was not known. Now I can write this. R1 का value is going to be 45 mm. Number of teeth they have given na, 30 teeth. Module they have given. So R value we can calculate. And if you have calculated R1, तो बेटे R2 कितना हो जाएगा? Just put this value of R1 here. R2 कितना आएगा? This R2 is coming out to be, you will get something. R2 कितना हो जाएगा? 120 minus 45. This is coming out to be 75 बेटा. R1 पता है, R2 पता है. Omega 2 is given. Omega 1 can be calculated very easily. Can I write omega 1 by omega 2 is equal to R2 by R1? Omega 1 we have to calculate. Omega 2 कितना है? 480 rpm is equal to R2. Just we have calculated 75 mm divided by R1 कितना है बेटे? This is 45. कितना हो जाएगा? This value is coming out to be 75 divided by 45 into 480. What is the value of omega 1? This is coming out to be 800 rpm. Is this clear to everyone? Is this clear to everyone? Answer is coming out to be 800 rpm. ठीक है ना? So examination में they can also ask questions based upon this radius correlation, you know, r is equal to mt by 2. This relation can be asked. Center distances, they may give number of teeth, they may have missing teeth. If somebody is asking ki bhaiya number of teeth calculate kar lo, how much number of teeth on gear 2 is going to be there, very easily we can tell. Radius pata hai na, once you know the radius, number of teeth can be calculated very easily. kaise likhenge? This r2 is equal to mt2 by 2 hota hai na, radius pata hai, t2 kitna ho jayega? This radius can be written as r2 ka value is given as 75 is equal to module is 3, t2 we have to calculate divided by 2, kitna ho jayega? 75 into 2 divided by 3, 50 teeth. So t2 is coming out to be 50 teeth. Easy. If they are asking. Clear hai beta? Let's move to the next question. Again 1 mark ka question hai. They have asked one question on epicyclic gear train, and epicyclic gear train ki questions ko how do we solve this? Let's have a look. An epicyclic gear train shown in the figure. The outer ring gear is fixed. One diagram they have given. This is the outer ring. Epicyclic gear train is shown in the figure. Outer ring gear is fixed while the sun gear rotate in counterclockwise direction at 100 rpm. Inside you are going to have sun gear, something like this. This is going to rotate at 100 rpm anti-clockwise direction mein. Let the number of teeth on sun, planet and outer gears are 50, 25 and 100. They are very, very polite examiner. They have given all the teeth. Sometimes examiner will miss some of these teeth. But that's not a major concern for us. We can calculate missing number of teeth with the help of radius correlation. If something is missing, they have given here all these 3 teeth. They have given by sun pe 50 teeth, planet pe 25 teeth and ring pe they have given 100 teeth. In case if they have missed any of these teeth, not a problem for us. We can very easily calculate it. Let me draw the diagram. This is how your gear train looks. Planetary gear train they have given. Outer ring they have fixed. ठीक है ना? अच्छा. Now imagine bete. Imagine if they have missed any of the teeth. They have given here, but in case if they have missed any of the teeth, we can easily calculate. Can I write here all these 3 gears, sun gear, planet gear and ring gear, they are going to have same module? Obviously baat hai. So whatever relation you are going to have in the number of, whatever relation you are going to have with the radius, same relation will be reflecting in your teeth. Can I write here radius of sun gear plus diameter of planet gear? Yahi to hai, same as radius of ring gear. Can I write radius of sun gear plus twice of radius of planet gear will be equal to radius of ring gear? Same relation number of teeth mein you are going to have because module is same for all the gears. Can I write teeth of sun plus twice of teeth of planet will be equal to teeth on ring? So if any one gear ka teeth is missing, sun ka teeth if they have given 50 teeth, this is 50 teeth. Ring pe 100 teeth they have given. Sun pe 50 teeth, ring pe they have 100 teeth. So in case if they have not given planet ke teeth, so this can be calculated very very easily. Planet pe number of teeth kitne ho jayenge? This is coming out to be 25. ठीक है, but again in this question they have not missed it. They have already given it. They are a good examiner. 50, 25 and 100 teeth. Clear hai number of teeth they have given? What is being asked? The ratio of magnitude of angular velocity of planet. Magnitude का ratio पूछ रहा है. Omega planet to the angular velocity of arm. To the angular velocity of arm. This ratio they are asking. How do we calculate this, beta? Ring gear ko they have fixed. Sun gear is rotating with anti-clockwise 100 RPM से. Sun gear का speed they have given omega of sun 100 anti-clockwise, यानी कि minus का 100 they have given. Getting a point? Ring gear के बारे में they have given information, sir. This is fixed. 0 RPM से घूम रहा है. You just have to write equation. You just have to write equation. कैसे लिखते हैं इक्वेशन बेटे? देखो, हाउ डू वी राइट इक्वेशन? इक्वेशन लिखी जाती है, सन का स्पीड यू नो, रिंग का स्पीड इज गिवन, बिटवीन सन एंड रिंग. अच्छा, प्लैनेट दे हैव आस्क्ड अबाउट प्लैनेट टू द आर्म. तो एक काम करो आप, राइट डाउन द इक्वेशन बिटवीन प्लैनेट एंड रिंग. हाउ डू वी राइट द इक्वेशन? एंगुलर वेलोसिटी ऑफ प्लैनेट विद रिस्पेक्ट टू, शॉर्टकट बता रहा हूं, एग्जामिनेशन में you don't have to make tabular method. This is going to be time taking. This method is very easy. Planet, angular velocity of planet. Planet is a driving ring. Omega p divided by omega ring. अच्छा, epicyclic gear train में you cannot write omega planet divided by omega ring is equal to teeth का reciprocal teeth of ring divided by teeth on planet. Internal meshing है तो positive sign. ना ना, directly you cannot write. Because here arm के rotation की वजह से this kind of equations are not valid. हाँ, if you sit on this arm, now whatever rotations you are seeing, if you sit on the arm, तो arm के rotations are not visible to you. Arm will be at rest from your point of view, na? Now you can write this equation, but if you are sitting at this arm, so whatever velocities you are going to see, those are not omega p, those are omega p with respect to arm, because you are on the moving frame. With respect to arm, with respect to arm. Getting my point? This is how you can write the equation, bete. Put down the values. Omega planet, they are asking omega planet minus arm का speed divided by ring का speed 0 दे रखा है, minus arm का speed, this is omega arm, is equal to planet internally drive कर रहा है, so we are having a positive sign here. Teeth on ring कितना है? This is 100. Teeth on planet कितने हैं बेटे? 25. This comes out to be 4. ठीक है ना? कितना हो जाएगा? ओमेगा p डिवाइड बाई ओमेगा r. ओमेगा p डिवाइड बाई ओमेगा r. और ये माइनस इधर ले जाइए. दिस इज माइनस का 4 माइनस ओमेगा आर्म बाई ओमेगा आर्म. दिस इज 1. ये 1 इधर जाएगा, दिस विल बी पॉजिटिव. तो ओमेगा प्लैनेट डिवाइड बाई ओमेगा आर्म. हाउ मच इज दिस बेटा? This is coming out to be how much? Minus 1 this side. Plus हो जाएगा. Minus 4 plus 1. Minus का 3. How much is the answer, beta? Answer is coming out to be minus 3. But you don't have to write minus here. Some people, some fellow are going to write minus 3 is my answer. Array, minus 3 you don't have to write. You will get wrong number. You will get negative marking, beta. You will get negative marking. तुमसे क्या पूछा? They have asked ratio of magnitudes only. So you don't have to put a negative sign. Negative sign नहीं लगाना है आपको. Getting a point? Don't have to put a negative sign. You have to write plus 3. Minus 3 is your answer. Take mod. Answer is going to be 3. This is your answer. Clear है? Clear बच्चे? Shall we proceed to the next question? So we have solved mechanism पे. They can ask question degree of freedom पे, quick return motion mechanism पे. Grashof-Slopic questions can be framed. Gears and gear train पे they can ask question number of teeth calculations पे. Center distance related questions can be framed. है ना? Gear train पे they can ask questions. And gear train में भी especially they are going to ask questions on epicyclic gear train. How do we solve that? That I have already shown to you. ठीक है ना? Yes, yes, yes. 3 is the answer. Next, we are going to discuss about kinematic and dynamic analysis of single slider crank mechanism. Again, I'm saying bete. यहाँ पर there are going to be few type of questions. Kinematic analysis में they are going to ask questions. You know, crank का velocity is given, piston का velocity they may ask, piston का acceleration they may ask. You have direct formulas. Velocity of slider is equal to r omega sin theta plus sin 2 theta divided by 2, and this is how you are having the formula. याद कर लीजिए, memorize these formulae. Examination में direct formula based questions can be asked. Acceleration, if somebody is asking acceleration of the piston, r omega square cos theta plus cos 2 theta divided by n. This is how you are having formula. Sometimes based upon direct formula questions can be framed. The second thing they are asking, the second kind of questions can be framed, that will be on dynamic analysis. How do we solve questions here, sir? Careful. देखो, एग्जामिनेशन में मोस्ट ऑफ द टाइम दे आर गोइंग टू गिव कि भैया net force acting on this piston, they will be giving, which you are going to call it as piston effort. Sometimes if it is not given, you have to calculate it. Most of the time, if I go back to the previous year questions, so whatever questions they have asked till date, 99% chances are there they have given this piston effort. How much piston effort is there, they will give you. They will give it to you. Examination mein it will be given. But sometimes if it is not given, you have to calculate this. And how do we calculate piston effort? Piston effort का मतलब होता है whatever the values are there, gaseous forces are there, add करिए, plus some gaseous pressure is there, and due to that some gaseous forces are there. You have to, these are the forces which are providing motion to the piston. This force minus whatever forces are opposing the motion, add करिए, friction force minus friction force, minus inertia force, whose value is ma. Acceleration just calculate कर लीजिए, how much is the acceleration of the piston. Formula I have written, mass will be given ma, this is the inertia force. Piston friction force कैसे calculate करते हैं? Mu times Fn, normal force, we will just calculate Fn. Getting your point? Acha, if we are having vertical mounted cylinder, so plus minus mg you also have to consider. Bhai, if vertically mounted engine is there, so in the direction of line of stroke, weight is also acting now. And this weight will be added or subtracted. It completely depends upon whether your piston is moving in downward direction, where mg is going to support the motion, or if piston is going upward direction में, तो फिर mg is going to oppose the motion. Getting your point? So whether piston is coming down or up, accordingly you will add or subtract mg. This is how you are going to calculate piston effort. And once you have calculated how much is the piston effort, so in terms of piston effort, all the values you have to calculate. ठीक है ना? You know, just take out components. You don't have to remember any of the formula. No formula at all. ठीक है? कोई formula याद नहीं करना है. Sir, कैसे लिखते हैं? This is the piston. On this piston, one piston effort. This is the piston effort. Fp is going to act. Fp is acting here. On the piston, from the connecting rod, one force will be there, which is called as force along the connecting rod. This is Fc. And one normal thrust to the cylinder is going to be there. This is something which is called as Fn. बात समझ में आ रही है? एंड ऑल दीज फोर्सेज आर गोइंग टू बी इन इक्विलिब्रियम. वी आर गोइंग टू कंसीडर दिस, है ना? इफ ऑल दीज फोर्सेज आर इन इक्विलिब्रियम, तो कैन आई राइट this is FP. These are in equilibrium. It means these forces are going to form a closed couple, closed diagram. Getting a point? Something like this. ठीक है ना? FP you have just calculated. This is FN. This is FC. This is angle beta. We call this angle as beta. This is the angle alpha. I hope you remember. Sorry, this is angle theta. Getting a point? In terms of FP, you have to calculate this FC force, FN force. Very easily we can calculate. Sir, FC, somebody is asking FC. So can I write FC cos beta? यही तो होता है. This is FP. FP calculate कर लिया है, तो FC can be written as FP divided by cos beta. Once FC is known, all other forces you can calculate. FC पता है, तो यही तो है FC, which will be acting here along the connecting rod, FC. And due to this FC, you are going to have two components. One component perpendicular to the crank, another component along this crank. Getting a point? Take out two components. This angle is going to be how much? External angle theta plus beta. Can I write radial thrust? This value is coming out to be FC ka cos theta plus beta component. This torque wala component, crank effort, we are going to call it as FT, can be written as FC ka sin theta plus beta component. Getting a point? If you know this diagram, if you can draw this diagram in the examination hall, very easily you can solve the question beta. Very easily, very easily. ठीक है ना? Let's have a look. One question, one big question we are going to do, and we will see all the concepts from here. ठीक है? क्या दिया हुआ है? A single cylinder, MSQ है, multiple select question, more than one options may be correct. A single cylinder vertical engine is shown in the figure. It has a bore. Bore मतलब cylinder का diameter they have given how much? Inner diameter is given as 30.5 centimeter. Okay. And a 80 centimeter long connecting rod. ठीक है? L का value they have given. Let me write. L का value they have given 80 centimeter. Stroke they have given as 40 centimeter. अच्छा, everybody knows. Can I write? Stroke का value होता है twice of R के बराबर, and this value is given as how much beta? This is 40 centimeter. 40 centimeter. तो can I write R का value is given as 20 centimeter? Is this clear? L का value they have given, R का value they have given. If needed, we can calculate value of N, which is equal to L by R. कितना हो जाएगा? This is 80 by 20, coming out to be 4. We just have calculated this. Piston का cylinder का inside diameter will be same as piston diameter. This thing, ये है piston, and this diameter is given as how much? But this diameter is given as bore diameter. This dia is given as bore 30.5 centimeter. This is given as 30.5 centimeter. Can I write? Mass of reciprocating. अच्छा, एक और चीज very important. They are talking about vertical engine. It means mg is going to be considered here. Mg will be considered here. Mass of the reciprocating part is given as 135 kg. So mass, let me write 135 kg. When the piston is at quarter stroke, quarter stroke का मतलब होता है and is moving in downward direction. Piston is traveling in downward direction. Okay. Piston is traveling in downward direction. The net pressure on this piston is 650 kilonewton per meter square. This pressure is given how much? Pressure is acting 650 kilonewton, यानी कि 10 to the power 3 Newton per. This is the pressure they have given. If the speed of engine is 250 rpm, which of the following is correct? Omega they have given. Omega is 250 rpm, means 2 pi n by 60, something radian per second. अच्छा, अच्छा. Options में what they have given? They are asking first option, force along connecting rod is 42.89 kilonewton. Is this correct or not? Turning moment on the crank is this much value. Acceleration of the piston is this, and piston effort is this. All these values you have to calculate and check which of these following are correct. ठीक है? सबसे पहले acceleration of the piston can be calculated very easily. एक्सेलरेशन का फॉर्मूला आई जस्ट हैव रिटन हियर. एक्सेलरेशन का फॉर्मूला क्या होता है बेटे? एक्सेलरेशन का फॉर्मूला होता है आर ओमेगा स्क्वायर. आर का वैल्यू दे हैव गिवन. आर का वैल्यू दे हैव गिवन. हाउ मच? 20 सेंटीमीटर. मीटर में पुट करना है. यू हैव टू पुट डाउन दिस वैल्यू इन मीटर्स. रेडियस का वैल्यू कितना दिया हुआ है? 20 सेंटीमीटर ना. 20 मीटर कितना हो जाएगा? 20 डिवाइड बाय 100. ओमेगा का वैल्यू वी जस्ट हैव रिटन 2 पाई n by 60. कितना हो जाएगा? ओमेगा का वैल्यू वी जस्ट हैव रिटन कितना हो जाएगा? दिस वैल्यू इज 2 पाई इंटू n by 60. दिस वैल्यू इज कमिंग आउट टू बी 26.1799 रेडियन पर सेकेंड. ओमेगा का वैल्यू रखिए बेटा यहां पर. हाउ मच? ओमेगा का वैल्यू रखिए. कितना आ जाएगा? दिस ओमेगा का वैल्यू इज 26.1799. थीटा का वैल्यू, n का वैल्यू इज गिवन. n is how much? But this is 4. Somehow if you can find out how much is the value of theta, acceleration is known to you. How do we calculate theta का वैल्यू? क्वेश्चन में they have said, they have given that your slider has moved to quarter of the stroke. Quarter of the stroke का मतलब होता है quarter of the stroke का क्या मतलब होता है? Very very careful. Again, people can do mistake here. बेटा, from here till here, है ना? This total distance is something which is known as a stroke. The very first mistake most of the students are going to do is, sir, when 180 degree angle we are going to travel, so फिर it will travel stroke this much distance. तो यहां पर it has traveled 1/4 distance. तो फिर यहां पर भी 1/4 एंगल 1/4 ऑफ द 180 डिग्री ट्रेवल किया होगा. बट ना, दिस कैन नॉट बी सेड. देखो, दिस crank is rotating with constant angular velocity, whereas this piston is going to have simple harmonic motion. So you directly cannot relate कि when it will be quarter, this will also be quarter. ना, we directly cannot say. Sometimes हो सकता है you may get your answers. Approach is wrong. Sometimes you may get right answers, but that will be just a coincidence. That will be just a coincidence. ठीक है? How do we calculate this? आप कहां पर हैं? Where are you right now? You are at stroke divided by 4 distance पे. Total stroke is given as how much? Or let me just write s by 4 distance पे you are there. है ना? How do we calculate theta here? इस theta का वैल्यू कैसे कैलकुलेट किया जाता है? बहुत ध्यान से. You are at this distance. We used to write this x as x is equal to, we used to write this as L plus R minus R cos theta plus L cos beta. Remember this? Total distance L plus R minus कर दीजिए. This is something which is R cos theta, and ये कितना हो जाएगा? This is L cos beta. This is angle beta. ठीक है ना? अच्छा, how do we write this? Cos beta को क्या लिख सकते हैं? Sir, we can write साइन बीटा होता है L sin beta. I hope you remember. L sin beta can be written as from these two triangles. Look here. Look at this diagram. If I draw a perpendicular here, can I write L sin beta वाला component ये है, R sin theta वाला component is also this. L sin beta is equal to R sin theta can be written. Can I write sin beta can be written what? Sin beta is equal to sin theta divided by n हो जाएगा, लिख सकते हैं. अच्छा, आई हैव टू राइट cos बीटा. cos बीटा क्या हो जाएगा बेटा? cos बीटा कैन बी रिटन एज 1 माइनस साइन स्क्वायर बीटा. साइन स्क्वायर बीटा की जगह पर यू आर गोइंग टू राइट साइन स्क्वायर थीटा बाई एन स्क्वायर. पुट डाउन द वैल्यू, यू विल गेट अंडर रूट 1 माइनस साइन स्क्वायर थीटा डिवाइड बाई एन स्क्वायर. अच्छा, we can say that n is large. n का वैल्यू लार्ज दे हैव गिवन 4 दिया हुआ है. जनरली n का वैल्यू लार्ज होता है एग्जामिनेशन में, whether they are saying it or not, you can always treat n as large value. And if n is large, can I say sin theta is less than 1? Sin square theta will be even smaller quantity, very small quantity divided by large का square, very large quantity, very small divided by very large. Can I say this term will be almost zero? Almost zero. And if this term is almost zero, so can I write cos beta को approximately under root 1? That means approximately 1 लिखा जा सकता है. And if this cos beta is approximately 1, तो फॉर्मूला क्या मिलेगा आपको? You will get L plus R minus R cos theta minus L cos beta. cos beta is approximately 1, तो approximately L लिख सकते हैं. Approximately ये L से L will get cancelled. क्या बचेगा? R minus R cos theta is equal to X. क्या दिया हुआ है आपको? स्ट्रोक का वैल्यू दे हैव गिवन हाउ मच? सॉरी, R का वैल्यू कितना दिया हुआ है आपको इन दिस क्वेश्चन? R का वैल्यू दे हैव गिवन हाउ मच? 20 सेंटीमीटर. स्ट्रोक का वैल्यू दिया हुआ है 40 सेंटीमीटर. स्ट्रोक दिया हुआ है 40 सेंटीमीटर. वेयर आर यू राइट नाउ? X is given as stroke divided by 4. क्वार्टर डिस्टेंस यू हैव ट्रेवल्ड ना, 1/4 डिस्टेंस यू हैव ट्रेवल्ड. तो x का वैल्यू दिया हुआ है क्वार्टर s by 4. दिस इज 10 सेंटीमीटर. पुट डाउन द वैल्यूज, यू विल गेट थीटा का वैल्यू कितना आ जाएगा बेटा? दिस इज x is given as 10 सेंटीमीटर इज इक्वल टू r कितना है बेटा? 20 minus 20 cos theta. Somebody please tell me what is the value of theta here? What is the value of theta here? कितना हो जाएगा? 20 cos theta this side, 10 this side, बचा 10. तो cos theta is equal to कितना हो जाएगा? Cos theta is equal to 10 by 20, 1 by 2. Theta is equal to 60 degree. अरे वाह, थीटा इज कमिंग आउट टू बी 60 डिग्री. यही आ रहा है बेटा, थीटा की वैल्यू इज कमिंग आउट टू बी 60 डिग्री. ठीक है ना? वंस यू नो थीटा का वैल्यू इज 60 डिग्री, प्लीज लेट मी नो. पुट डाउन द वैल्यूज हियर. रखिए यहां पर, थीटा की जगह पर रखेंगे 60 डिग्री एंड यू विल गेट हाउ मच इज द एक्सेलरेशन. Somebody please tell me how much is the acceleration. Calculate करिए, बताइए how much is the acceleration. All the values I have told. Acceleration पता चल जाएगा, something meter per second square. Everybody please let me know. Try to calculate and tell me beta how much is the answer. How much is the answer? बताइए बताइए बताइए. I am just waiting for you. एक्सेलरेशन का वैल्यू कितना आ गया? If you will calculate this, you are getting 51 point something, 51.4 मीटर पर सेकंड स्क्वायर. ठीक है ना? cos 60 plus cos 120 divided by 4. $51.4040 meter per second square. The very first question they have asked, acceleration of the piston is how much? 51.404. क्या ये ऑप्शन सही है बेटा? Is it correct? Option C is correct. क्वेश्चन सॉल्व करने का अप्रोच को इंक्रीज कैसे करें बेटे? लास्ट 10-15 days are left, so nothing much can be done. You just do one thing: solve as many questions as possible, and don't jump onto unsolved questions at this moment, because if some unsolved question you are going to solve, you don't even know whether you are right or wrong. If you want to learn something ki bhai I cannot solve this question, so what will be the correct answer? You will end up wasting your time. So at last these 10-15 days I will give you one honest advice: try to solve as many questions as possible and go for solved questions. That means whatever questions you have solved in this entire year, try to revise all those questions, all those concepts. Don't go for any new concept. Clear hai na? Acceleration, this part is correct. What else they have asked? Acha, theta you have calculated, so very easily you can calculate beta also. If you have calculated theta, so somebody please tell me what is going to be the beta value. Sir, sin beta hota hai, we know. Sin beta is equal to sin theta divided by n hota hai na. Put down the value. कितना हो जाएगा? Sin theta 60 degree divided by n की वैल्यू 4, कितना हो जाएगा? This is sin 60. Whatever is the answer divided by 4. Whatever is the answer, sin inverse 12.50. Beta का वैल्यू is coming out to be 12.50 39 degree. This is the answer of beta. थीटा का वैल्यू पता है, बीटा का वैल्यू पता है. Try to calculate piston effort, and then rest all these things can be calculated. Once you know the piston effort, force along the connecting rod can be calculated, turning moment on the crank can be calculated. Piston effort, how do we calculate बेटा? Piston effort के लिए कैसे बात करेंगे? Piston effort क्या होता है? देखो सर, piston effort निकालने के लिए whatever is the gaseous force you have to calculate minus friction forces. Friction के बारे में they have said nothing, so we will consider कि भैया friction नहीं है, there is no friction at all. If they have given अभी फिलहाल के लिए we are considering it to be 0 because they have not talked anything about mu, coefficient of friction they have not given, so this will be treated as 0. Then we have minus inertia force whose value is ma. Mass is given, acceleration is given. mg के बारे में क्या ख्याल है? What is going to be the mg? Sir, piston is coming downward direction में, weight is acting on the downward direction, तो plus mg you are going to write. Solve it. कितना हो जाएगा? How much is the gaseous force? बटा gaseous force is going to be pressure multiplied by whatever is the area. Area कितना होता है? pi by 4 d square. Diameter कितना है? Piston का diameter they have given how much? 30.5 centimeter. Meter में don't forget to convert this into meter. Diameter is how much? You have to write. Minus inertia force is ma plus mg. Put down the value. Pressure is given as how much beta? Pressure is given as 650 into 10 to the power 3. 650 into 10 to the power 3 into pi by 4 into diameter कितना है? How much is the diameter? Diameter is given as 30.5 centimeter, यानी कि 0.305 square. Minus m कॉमन ले लीजिए. Mass is how much? 135 kg. Inside the bracket you are going to have minus का acceleration. Minus acceleration you just have calculated. How much is the minus acceleration बेटे? एक्सीलरेशन v जस्ट हैव कैलकुलेटेड, कितना आया है 51.404, 51.404 प्लस ग्रेविटी कितना होता है 9.81. Try to solve this, you will get piston effort. Anybody who can tell me what is the value of piston effort, beta? Anybody who can tell me what is the answer here? Once you will solve all these values, piston effort का जो आंसर आ रहा है मेरे पास, I am getting whatever values you are going to get, that will be 41.875 into 10 to the power 3 Newton. You will get this value. And piston effort की value they have given in, they are asking in kilonewton, 47.49. This is not correct, beta. 41 point something is my answer. This is incorrect. This is incorrect. ठीक है ना? अच्छा, piston effort they were asking 47 point something. My answer is 41 point something. It means option D is incorrect. Rest what they are asking force along the connecting rod कितना होगा, FC का value they are asking. How do we calculate FC? अरे भाई, just I have written here. कहाँ लिखा था, इधर आ जाओ. Can I write FC is how much? FP by cos beta. कितना value हो जाएगा? FC is equal to FP. Just we have calculated how much was the FP beta. FP का value था 41.875 kilonewton divided by cos beta, और beta का value was how much? 12 point something I think. Beta का value was 12.5039. 12.5039. Put down the value. 12.5039 degree. So force along connecting rod is how much? कितना आ गया? कितना आएगा ये value? This value FC is coming out to be a little calculation. My FC is coming out to be 42.89. 42.89 kilonewton. Check करिए whether this is correct or not. Yes, force along the connecting rod they are giving as 42.89. Option A is correct. And last में they are asking turning moment on the crank, बताओ how much is going to be this turning moment. And how do we calculate turning moment? अरे भाई, turning moment के लिए if you know the FC का value, FC के components, this FT crank effort and crank effort multiplied by this radius, यही तो होता है torque. कैलकुलेट कर सकते हैं. हाउ मच इज द वैल्यू? क्रैंक एफर्ट मल्टीप्लाइड बाय रेडियस, यही तो होता है टॉर्क. एफटी की वैल्यू कितनी हो जाएगी? दिस एफटी का वैल्यू कितना हो जाएगा? दिस एफटी कैन बी रिटन एज एफसी साइन थीटा प्लस बीटा. एफसी साइन थीटा प्लस बीटा टाइम्स आर. एफसी जस्ट वी हैव कैलकुलेटेड हाउ मच वाज एफसी? 42.89. 42.89 किलो न्यूटन में है दिस वैल्यू. कीप इन माइंड साइन थीटा प्लस बीटा साइन 60 प्लस 12 पॉइंट, हाउ मच वाज बीटा? 5039 डिग्री मल्टीप्लाइड बाय रेडियस कितना दे रखा है? 20 सेंटीमीटर. रेडियस इज गिवन एज 20 सेंटीमीटर, यानी कि दिस इज 0.2. whatever you will get, that will be torque, and answer is going to be in kilonewton. Keep in mind this value you have kept in kilonewton and radius you have kept in meter, so answer you are going to get in kilonewton meter. Everybody clear or not? Okay, the answer which I am going to get here is 8.1809 kilonewton per meter. Check करिए whether this option is correct or not. 8.1809 is my answer, approximately correct. So option B is also correct. Which options are correct? MSQ में option A, B, C are correct. one big question and all the concepts are clear. How do we calculate this angle theta? I have told you. How do we calculate velocity and acceleration? I have told you. How do we take components of forces? How do we calculate force along connecting rod, crank effort, turning moment? Everything is asked. Option A, B and C are correct. D is not correct. Even we have seen how do we calculate piston effort. ठीक है ना? बात समझ में आ रही है बेटा? ठीक है, चलो नेक्स्ट लेट्स टॉक अबाउट फ्लाईव्हील. अच्छा, फ्लाईव्हील में मोस्ट ऑफ द टाइम very easy questions are asked. Very easy questions are asked. Very easy. What is given? Torque exerted on the crankshaft. They have given T is equal to 5000 plus 1000 sine 2 theta minus 1200 cos 2 theta, where theta is the crank angle as measured from inner dead center position. Assuming the resisting torque to be constant, power in kilowatts developed by engine at 120 rpm is how much? They are asking power. And how do we calculate power? Very easy question, beta. It should not take more than 10 seconds. Power of any engine, if they are asking, so power can be written as क्या होता है power? Power is equal to mean torque into mean omega. And how do we calculate mean torque developed by the engine? Engine का torque they have given. Engine का torque is how much? Torque available या फिर torque of the engine. How much is given? This is 5000 plus 1000 sine 2 theta minus 1200 cos 2 theta, something like this, Newton meter. This torque they have given. Acha, engine is developing this much amount of the torque. Torque ki whatever values they have given, the term which is independent of theta, this term, yahi to hai which represents your mean torque. So mean torque is directly given. Kitna hai? This is 5000 Newton meter. From the value 5000 Newton meter. Velocity they have given 120 rpm पे it is running. निकाल लो वैल्यू. ओमेगा कितना हो जाएगा? This is coming out to be 2 pi n by 60. 120 divided by 60. You will get your answer. Answer is going to be in watt. Please convert this into kilowatt. How much is the answer, beta? 2 pi into n यानी 120 by 60 कितना हो जाएगा? This is 2 into 5. 62.83. My answer is coming out to be 62.83. 62.83 into 10 h power 3 watt. You can write 62.83 kilowatt is going to be your answer. I hope everybody is clear. I hope everybody is clear. 62.83 is coming out to be my answer. ठीक है ना? Easy है बेटा, not difficult at all. Shall we proceed to the next part? What else they have given? Let's talk about some questions which are from vibration. Again, vibration say, so many questions, literally so many questions can be framed. I find it very difficult when I say vibration mein this is important and this is not important. Vibration ka each and every part is going to be important. Whether it is natural frequency wale questions or damped vibrations mein they are asking damped frequency is how much? Omega d is equal to omega n under root 1 minus theta square. Or simply they have asked try to calculate zeta. They have given you the equation of motion and they are asking try to calculate the zeta ka value. or even if they are asking forced vibration mein magnification factor ke questions are there, transmissibility ke questions are there, some big formulas you are going to have. So many questions can be framed, everything is important here. Vibration chapter mein each and every line is going to be important. From where they can ask question, nobody can judge. Okay, I have some good conceptual questions, and let's try to learn something new here. Numerical answer type question hai 2 mark ka question. Shaft fixed at ends. Just a moment. Let's try to solve this question. A vibrating system is described by equation. Vibrating system is described by equation 16x double dot plus 5x dot plus 4x. They have given you one equation. They have given you this equation. What they are asking? The frequency of vibration at which magnification factor is going to be maximum. Nowadays, they have started asking question on this part also. Acha. First of all, you must know what is given here, what they are asking. But a magnification factor के graphs तो पता होंगे ना? How does it look? Magnification factor. And here frequency ratio omega by omega n. I hope you remember. Very big formulas you are going to have here. Magnification factor का formula I hope you remember. This was 1 upon under root के अंदर 1 minus omega by omega n square whole square plus 2 zeta omega by omega n square. I hope you remember this. बात समझ में आ रही है? If you look at the diagram was somewhere. This is magnification factor 1 and this was resonance wala line. Something like this. You have the diagram. For zeta is equal to 0 ke liye, if you are going to draw the diagram, it will be something like infinity say you are going to take turn. And this was the graph. Zeta is equal to 0 ke liye. For any other zeta, if you are going to draw the diagram, so peak will shift lower. Yahan par peak is at infinity and at resonance. Getting a point? You are getting peak at resonance. Exactly at resonance, magnification factor is highest. And how much is the value of this highest magnification factor? Infinity. Rest any other zeta ke liye, if you will draw the graph will be somewhere here. Zeta ki value, say for example, this is 0.5. Keep on increasing zeta ka value. Graph will be this. Zeta ka value, this is 0. Keep on increasing value. This is 0.5. This is 0.8. If zeta ka value is, suppose, more than 1, more than or equal to 1, so peak is here itself and graph will be this. Zeta, anything more than or equal to 1, graph will be this green wala. बात समझ में आ रही है? What they are asking? Equation में they have given something. Equation they have given. अच्छा, equation is given, तो फिर easily you can find out zeta का value कितना है. बहुत ध्यान से. Equation क्या दे रखी है? This is 16x double dot. 16x double dot plus 5x dot plus 4x is equal to 0. Can I compare this with ये है? This is your sx double dot plus cx dot plus sx is equal to 0. All these values are given. Zeta can be calculated very easily. Zeta कितना होता है बेटे? This zeta can be written as c divided by 2 under root sm. Everything is given. C का value कितना है? This is 5 divided by 2 under root. S कितना है? This is 16 into m कितना है? This is 4. कितना हो जाएगा? This is 5 divided by, I don't even need the calculator here. 4 into 2 बाहर आ जाएगा. This will be 4 to the 8. 5 by 16. This value comes out to be how much? 5 by 16. This value is 0.3125. 0.3125. This is the value of zeta. Damping factor, damping ratio. You have calculated. ठीक है ना? अच्छा, दिख गया कि सर ये विच काइंड ऑफ डायग्राम दे आर टॉकिंग. दिस इज नॉट जीटा का वैल्यू जीरो, जीटा की वैल्यू जीरो नहीं दे रखी है. अदरवाइज आई विल डेफिनेटली से कि वेयर एट व्हाट फ्रीक्वेंसी यू आर गोइंग टू हैव पीक. नेचुरल फ्रीक्वेंसी पर, रेजोनेंस पर. अच्छा, zeta की some value they have given which is 0.3 something. So these kind of graph you are going to have, and at what value, exactly what value you are going to have peak, this they are asking. Clear hai? And how do we solve this kind of questions? Sir, magnification factor will be maximum when this value is going to be minimum, and this value is going to be minimum when at what value of omega. That can be calculated very easily with the help of maxima minima wala concept. ठीक है ना? There is some general formula for that also. If you remember that formula, that formula can be written as कि भाई we will get peak at some omega star, and that omega star का value is given as omega n under root 1 minus 2 zeta square. If you remember this formula, so far so good. How do we get this? बात समझ में आ रही है कैसे निकला होगा ये? सर, when this value is going to be minimum, when this value is going to be minimum, you are going to get your maximum value. And how do we take the minima of this? Sir, 12th standard we are studying this. Any function under root, just avoid the under root. What is the function written over here? 1 minus omega by omega n. Omega by omega n ko if I am writing frequency ratio r, 1 minus omega by omega n square whole square plus 2 zeta omega by omega n is again r square. When this is going to be minimum, at what value of r, यही तो आइडेंटिफाई करना है. तो डिफरेंशिएट कर लीजिए dy by dr, डिफरेंशिएट करिए, you will get something and then equate this to be 0. You will get some value of r. R का मतलब frequency ratio you will get at omega by omega n का ratio you will get, and from here you can write omega by omega n का ratio is this much. This is something इसको further I am going to say this omega star. So what is that omega where this function is minimum? This value omega is omega n times 1 minus twice of zeta square. Everything is given, सब कुछ दे रखा है आपको. Just put down the value. Zeta का value put down कर दीजिए. Zeta you have just calculated. Put down the value of zeta. Omega n. That's it. Omega का value you are going to get. Getting a point? Try करिए and बताइए बेटे. Zeta का value is already known to you. Zeta का value पता है. Omega n और calculate कर लीजिए. How much is omega n बेटे? Omega n कितना है? Under root s by m. कितना हो जाएगा? s कितना है? 16. मास कितना है? सॉरी, अरे दिस इज mx डबल डॉट cx डॉट प्लस sx अंडर रूट s कितना है बेटे? s की वैल्यू इज गिवन एज 4 डिवाइड बाई हाउ मच इज द मास? 16. कितना हो जाएगा? 4 4 1 बाई 2. 1 बाई 2 का मतलब 0.5. पुट डाउन द वैल्यूज, यू विल गेट योर आंसर. क्या आंसर आ रहा है बेटे? एनीवन हु कैन टेल मी? ओमेगा स्टार कैन बी रिटन एज ओमेगा n की वैल्यू है 0.5 अंडर रूट 1 माइनस 2 इंटू जीटा स्क्वायर. हाउ मच इज द जीटा का वैल्यू बेटे? जस्ट वी हैव कैलकुलेटेड. जीटा की वैल्यू है 0.3125. 0.315 स्क्वायर. सॉल्व करिए एंड टेल मी व्हाट इज आंसर. 0.315 स्क्वायर इंटू 2 1 माइनस आंसर अंडर रूट 2.5 0.4485. ओमेगा स्टार की वैल्यू आ रही है. दिस इज 0.4485 रेडियन पर सेकेंड. विच ऑप्शन इज करेक्ट? Which option is correct? 0.4485. Can I write 0.4485 approximately as 0.45? Which option? Option B, Bombay is correct. देखो, examination में you don't have to do this derivation. Examination में you just have to remember the formula. Getting a point? Omega star, where peak is going to be there. is equal to omega n under root 1 minus 2 zeta square. That's it. Everybody clear? Everybody clear? ठीक है ना? Shall we proceed? Another question. Have a look at this question. MCQ है. Consider a harmonic motion. X is equal to something sine something 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 something. They have given. Match the list 1 with the list 2 and select the correct answer using codes given below. Option list 1 में they have given what is the amplitude, what is the frequency, what is the phase angle, what is the time period, and here they have given some values. ठीक है? Equation of motion they have given x, the solution of equation they have given, है ना? X is equal to, अच्छा, can I write? हम लोगों को मालूम है x is equal to a sin omega t minus phi. ऐसा ही तो कुछ आंसर आता है बेटे. इसका मतलब द वेरी फर्स्ट टर्म विच इज रिटन हेयर, यही तो है आपका एम्पलीट्यूड. तो एम्पलीट्यूड इन सेंटीमीटर्स कितना है? 1.25. ए के साथ में यू आर गोइंग टू हैव 2. ए के साथ में 2, ए के साथ में 2 होगा. ऑप्शन ए गलत है, सी गलत है. फेज एंगल कितना दिया हुआ है? फेज एंगल इज पाई का वैल्यू दे हैव गिवन एज पाई बाय 6. phase angle pi by something is missing, something is wrong. Phase angle का value they have given pi by 6. There is no answer such as pi by 6. Okay, some printing mistake is there. Some printing mistake is there. Again, rest of the things let's. Time period is how much? Time period. अरे भाई, omega is given ना? If omega is given, omega is 2 pi by t. Time period कितना हो जाएगा बेटे? Omega का value is how much? Omega is given as 5. So 5. Time period कितना हो जाएगा? This time period will be equal to 2 pi by 5. Second. Time period का value they are asking? 2 pi by 5. 2 pi by 5 कहाँ दिखाई पड़ रहा है? 2 pi by 5. D के साथ में we are having 3. D के साथ में we are having 3. है ना? And frequency पूछ रहा है cycles per second hertz में. Can I write omega को we can also write 2 pi f. F can be written as omega कितना है बेटे? Omega is 5 divided by 2 pi. So 5 by 2 pi hertz. This is frequency. 5 divided by 2 pi. Frequency 5 divided by 2 pi 1. B के साथ में we are having 1. C के साथ में we are going to be having 4. And this option is not correct. So let me. It must be written as pi by 6. It's printing mistake बेटे. होता है, कभी कभी होता है. Pi by 6. Value must be pi by 6. ठीक है ना? Which option? Option D, Delhi is correct. Which option? Option D, Delhi is correct. All good? All set? Till this point, anybody, if you are having any problem, please let me know in the chat box. All good, all good. Everybody comfortable? चलिए. Suppose examination में they have asked a question, another question for 2 marks, and believe me, bete, you must go through all these questions. Those who are going to watch this session recorded, please solve all the questions, because these are highly expected questions for GATE 2023. You will definitely get 1 or 2 questions from this session. From this short session, there are 10-15 questions which I am presenting here. You will get definitely something out of here. A shaft 60 mm in diameter and 2-meter long, 2-meter length, carries a disc which has mass eccentricity which is equal to 190 microns. Eccentricity they have given. Eccentricity they have given 190 micrometer, यानी कि 190. अच्छा, आंसर भी they have asked in micrometer, so I will not convert any units. 190 micrometer. Displacement of the shaft at a speed which is 90% of the critical speed. अच्छा, shaft की critical speed क्या होती है? Omega n, natural frequency. When your shaft is rotating at 90% of the critical speed, यानी कि shaft का omega they have given as 90% of critical speed, something like this. This value they have given, यानी कि omega n by omega. How much is this? Omega n by omega कितना दिया हुआ है? Omega n by omega is given as 100 by 90. This they have given. क्या पूछ रहे हैं? Displacement of the shaft, how much is going to be there? कितना हो जाएगा displacement of the shaft? बेटा देखो, this is your shaft, ये आपका shaft है, this is the rotor, ये rotor है, eccentricity they have given, this eccentricity they have given, center of mass, suppose it is somewhere here, and when this system is going to have rotation, ये rotate करेगा, can I say this is shaft axis of the rotation, this shaft का axis is going to bend हो जाएगा. आपसे वही तो पूछ रहे हैं, आपसे वही तो पूछ रहे हैं. And how do we calculate that displacement of the shaft? आपसे पूछा है. How do we calculate that? We were having direct formula over here. Phi is equal to eccentricity divided by omega n by omega square minus 1. I hope you remember this formula. Class में we have already discussed this. Direct formula is there. Put down the values, you will get your answer. Eccentricity is given. Displacement y का value they are asking in micrometer na, so e का value I will put in micrometer only. Eccentricity is given a how much? 190 micrometer divided by omega n by omega का value they have given how much? Omega n by omega value is given as 100 by 90. Put down the value, 100 by 90 square minus 1. ठीक है ना? Y का value you will get, whatever value you are going to get, that will be in micrometer. Please let me know in the chat box what is the value. What is the value? 100 divided by 90 square minus 1. Whatever you have got, 190 divided by answer 810. 810 micrometer. This is your answer. 810 is going to be your answer. Clear है बेटा? ठीक है ना? Direct formula based question was there. So this is how they can ask questions on vibration. Vibration mein one more question I have for you. These kind of questions can be solved how? A single degree of freedom system is shown in the figure. It consists of a massless bar, point A to B. This distance is given, L distance. Midpoint pe one spring is there, end pe one spring is there, 200 Newton per meter, 200 Newton per meter. Two springs are there which are supporting your, rod and mass. And they have clearly mentioned here. That rod is massless. Rod is given massless to you. ठीक है ना? Rod massless दे रखी है. End पे they have only one mass. How much? 2 kg. Natural frequency of this system बताओ in radian per second. How much it will be? कितना हो जाएगा natural frequency? अच्छा, can you imagine that this question can be solved by two different methods? First one, I can solve this question either by torque method. क्यों sir? Absolute rotations can be seen about this eye center ना. This link is going to have rotation like this, oscillations. So about this point A, I can use either torque method या फिर I can also use relay method. क्यों relay method क्यों use कर पा रहा है? Because there is only one mass. Rod में there is no mass. Rod में there is no mass at all. आप you can use either relay method or torque method. This is completely up to you. Answers are going to be exactly same. But keep in mind, relay method, why I can use two different methods. Sir, torque method is general method. Everywhere you can use it. But relay method ke liye, there was a big condition that there should be only one mass, and here only one mass is there. Getting a point? I can use relay method also. I will solve this question by both these methods. बहुत ध्यान से, बहुत 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 ध्यान से. Careful beta. This is fixed point. One spring I have connected over here. Another spring I have connected over here. Both these springs are having same stiffness. S का value 200 Newton per meter. S का value यहाँ पर भी, this is 200 Newton per meter. One mass you have connected over here. This is mass M. Mass M value is given as 2 kg. I hope this is correct. This value is given as L. This is length L. And ये भी आपका, this is also length L. है ना? First, let's solve it with the help of relay method. कैसे सॉल्व कर सकते हैं बेटा? With the help of relay method. अरे भाई, this was the initial position, and once you will leave it, due to weight, it will try to come down, and springs के deflections are going to balance this. Somewhere it will stop, and that is something which I'm going to call it as its equilibrium position. Equilibrium position looks somewhere here. है ना? So how much is the deflection of mass? You have to calculate that. Mass was initially here, finally it has reached here, and this distance, यही तो होता है, which you call it as static deflection of the mass. Can you calculate this? Calculate कर सकते हैं बेटा? अच्छा, if this value is delta, this value will be how much? Obviously बात है, this is going to be delta by 2. ठीक है ना? At mean position, weight के torque has been balanced by springs के torque. About this point, torque balance कर लीजिए बेटे. Can I write? This spring weight का torque कितना हो जाएगा about this point? mg multiplied by twice of L clockwise direction में. It will be balanced by anti-clockwise torque of the springs. First spring is applying how much torque? Yellow color से I am writing it. कितना हो जाएगा? This is coming out to be S times, how much is the deflection? Delta by 2. This is the force in upward direction multiplied by length L, anti-clockwise torque, plus this spring, it is also applying some force. Sir, deflection is delta, applying force in upward direction, this force multiplied by 2L, कितना हो जाएगा? This is S times delta into 2L, again anti-clockwise torque. Can I write? कितना हो जाएगा? This is mg L will be equal to 2 to the 4 5 by 2 S delta L. Few things are getting cancelled. This L say L will get cancelled. You can calculate delta का value कितना हो जाएगा? This delta का value is coming out to be, this delta is coming out to be 2 to the 4 mg divided by 5s. That's it. हो गया answer. You have this delta का value. Delta का value is known to you. How do you write omega n beta? Omega n कितना हो जाएगा? This omega n can be written as under root by delta. Delta का value is known. Deflection of the mass is known. Put down the value here. कितना हो जाएगा? Under root g by delta कितना हो जाएगा? This is under root divided by delta is how much? 4 mg divided by 5s. ऊपर चला गया. This is 5s. g gets cancelled. What you will be left? 5s divided by 4m under root में. This is omega n. Values they have given. Put down the value. कितना हो जाएगा? 5 into s यानी कि 5 into 200 1000 divided by 4m यानी कि 8 1000 divided by 8. Value is how much? Omega n in radian per second. You will get something. कितना आ जाएगा? This value is coming out to be how much बेटा? 1000 divided by 8 under root 11.18. 11.18. ठीक है ना? 11.18 is coming out to be answer. Cross check कर लीजिए. Is this the correct answer? If you want, you can also solve this question by same question with the help of torque method also. You will get the same answer. देखो, in torque method, how do we torque? Sir, from where this torque method can be applied? From this eye center. From where absolute rotations can be seen. So sit down here and from here you can talk about torque method. क्या हो जाएगा? When I saw the system about its mean position, it was having oscillation. When I saw at general time t, mean position say it has traveled through theta angle. This angle is theta. And it is further moving in theta dot velocity with the theta dot velocity and theta double dot acceleration. Clear है ना? Sir, this is theta. Write down all the torques. This is the horizontal wala position. Keep in mind, weight is not going to restore. Weight is not going to participate in the restoration. ठीक है ना? Theta is given in clockwise direction. This spring will give you some torque. How much? Yellow color say I am writing. How much will be this value? S times L theta multiplied by L. S L square theta हो गया. This is the torque. Another spring is there. This will be applying some torque also. कितना हो जाएगा? Again, anti-clockwise direction में it will be how much? Stiffness is S. What is the distance? 2L. Theta into 2L. Again square. ठीक है ना? There is nothing else. बुलाइए D'Alembert भाई साहब को. D'Alembert will introduce inertia force I theta dot dot and everything will become 0. Keep in mind, what is the value of I here? This I will be center of mass. Say there is only from this center of rotation there is only one mass m at 2L distance. So ml square. ml कितना है बेटे? L square. How much will be this? 4 times ml square. This is going to be your inertia. Put down the value. आई थीटा डॉट डॉट प्लस कितना हो जाएगा एस 4l² SL² 5 SL² थीटा इज इक्वल टू 0। आई की वैल्यू कितनी है 4ml² थीटा डॉट डॉट प्लस 5 SL² थीटा इज इक्वल टू 0। फ्यू थिंग्स आर गेटिंग कैंसिल हियर, L² से L² उड़ गया, यू आर लेफ्ट विद थीटा डॉट डॉट प्लस 5s डिवाइड बाई 4m theta is equal to 0। Can I say ये वैल्यू, दिस वैल्यू यही तो है which is representing omega n square under root 5s by 4m। same answer we have got here, 5s by 4m। do you solve, whether you solve it by Rayleigh method or you solve it by torque method, you are going to get the same answer, getting a point? But my dear, in case this question will be a little bit difficult, if they are saying same question, if rod also has mass, let me write, if rod has mass capital M, rod ka mass they have given capital M, small m mass is there, capital M mass rod ka they have given. Now you cannot solve this question with the help of Rayleigh method. Everybody, can you understand this? Rod ka mass negligible, bete rod mass, question में it is mentioned, rod is massless, figure consists of massless rod, rod massless, they have given massless rod दिया हुआ था ना, massless bar। but in case if rod is also having mass, Rayleigh method now you cannot use, Rayleigh method you cannot use। why? rod के पास distributed mass है, one concentrated mass here, Rayleigh method की there was one big condition कि भैया there should be only one mass and that too concentrated, so rod is also having distributed mass, point mass small m is there, rod is also having mass, Rayleigh method cannot be used। now you are left with only one option, you have to use torque method, getting a point? and now how do you solve it? कैसे solve करेंगे बेटा, कैसे solve करेंगे? let me write, same बातें sir, this rod from its mean position it was traveling by some angle theta, when I saw this it is traveling through angle theta in clockwise direction with theta dot velocity alpha acceleration। write down what are the torques which can be acting here। this is spring, yellow color wala spring, it will be applying some torque, kitna ho jayega, that torque can be written as s times, this is distance L square theta। this spring it is also applying some torque, kitna ho jayega, s times 12, same as the previous case, theta 2L square theta, there is nothing else, D'Alembert principle, D'Alembert's inertia force, I theta dot dot, but this time how much this I is going to be there, inertia, moment of inertia will be about this point, first of all rod ka inertia about this point you have to write, rod का inertia ml² by 12 होता है, about one end if you will write ml² by 3 होता है, तो ml² by 3, capital M, length कितनी है twice L, ml² by 3, rod का inertia of the rod, this is inertia of rod plus inertia of small m, all these things you have to add, plus कितना हो जाएगा, inertia of small m was small m L², length, how much is the length, twice L square, solve कर लीजिए, you will get something, this value of inertia you have to put now, बात समझ में आ रही है, this value of inertia you have to put it now, ठीक है, equation is same, I theta dot dot plus ये कितना हो जाएगा 5 times S L square theta is equal to 0, but inertia This time, this inertia is going to be here. Everybody can understand this? Everybody, can you feel it or not, beta? बात समझ आ रही है? Only point mass is there. You have a choice, either Rayleigh method or torque method. If multiple masses are there, point mass is given. Rod is also having mass. You cannot apply Rayleigh method. You just cannot apply Rayleigh method. Is this clear to everyone? बच्चा पूछ रहा है, if spring is also having mass, now what will we do? आ जाओ, let's make it a little bit more difficult. बेटा 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 मेरी जान, we have studied, sir, this is stiffness spring which is having stiffness S. We have one mass m here. How much is the natural frequency? Omega n होता है under root S by m. If somebody is saying, भाई this spring is also having mass ms, तो फिर this springs के masses we used to add here as ms by 3. Remember this? So can I treat this question where a spring which is having mass ms and end mein we have point mass m? Formula comes out to be this. By looking at this formula, one student said, sir, I feel that there is only one spring which is having stiffness S, and below you are having one mass small m, mass of the block, or spring ka mass you have put it here as ms by 3. So whenever spring is having mass and you have to solve that question, what you will do? What you will do? सर ये है रॉड, बहुत ध्यान से, बहुत ध्यान से. This S1 stiffness, M S1 is the mass. एक और S2 stiffness, MS2 is the mass. This is block which is having mass m. How do you solve this question? You can convert this question. Question is given something like this. You can write this question in such a manner कि भैया ये जो मास ms है ना, ms1 स्प्रिंग पे नहीं है सर, स्मॉल छोटा सा मास ms1 divided by 3 here. Getting a point? This ms2 mass is not here. ms2 mass you will put here, small chota sa mass here, ms2 divided by 3. Getting a point? This is how you are going to solve it. Now you can solve this question or not. Simple, springs are there. We have small m mass, ms2 by 3 mass, ms1 by 3 mass. These are the masses. Now you can easily solve this question, beta. Chaudhary Saab, it's clear to you? क्लियर है बेटे? ठीक है ना? ठीक है. So these were the questions which I had to discuss with you people. ठीक है ना? Today we have discussed some beautiful questions, and believe me bete, these are the some important topics which I have taken for you, and from those important topics the most expected questions which can be asked this year, I have shown those questions. Clear hai na? We will stop here. After me Amit Maurya sir is going to take session. Approve sir ka session hai. So let's stop here. But again I am saying, in these last 10 days, nothing much can be done. whether you have prepared throughout the year or you are just started preparation for in last few months, in last remaining days, what you should do is whatever you have studied, whatever you are comfortable in, just go through those topics only. Don't try anything new. Just don't try anything new. If you have prepared throughout the year, so whatever syllabus you have covered, just keep revising that. Keep revising that. Whatever numericals till now you have solved, just keep practicing those numericals. Don't try something new. Why I am saying don't try something new? Because if any new question is there, which may be simple, maybe a little bit tricky, maybe a little bit difficult, if that new question you are going to solve, and if you cannot solve that question, bete, it will hamper your confidence. And at last moment, you cannot afford to lose your confidence. Confidence is going to play a very important role in the examination. So last 10 days mein don't do anything which can hamper your confidence. समझ रहे हैं? Whatever you have collected in your mind, just recall, recollect again and again and again till the examination. Go to the examination hall with a high confidence and success will be completely yours, beta. ठीक है ना? Just don't try anything new. If you have left some topic, suppose somebody is saying, sir, power plant I haven't studied, IC engine I haven't studied, or any subject RAC I haven't studied. So just leave that. Even if Brahma is coming and saying, ki aao, I will teach you this subject, just say, bhaiya, for next year. For this time, only 10 days are left. I will focus only on that topic, only on that subject, only on those portions which I have already completed. हमें नहीं पढ़ना आपसे. Clear है ना? So last 10 days में no new experiment बेटे. ठीक है? Let's stop here. We will meet very soon with some more interesting videos. Till the time, thank you बच्चों. Goodbye. Love you all मेरी जान.